October 29th, 2025. While astronomers worldwide celebrate the perihelion passage of Three-Eye Atlas, the third confirmed interstellar visitor to grace our solar system, something far more unsettling is unfolding right beneath our feet. Earth's magnetic field, the invisible guardian that has shielded life for billions of years, is deteriorating at an alarming pace. The South Atlantic Anomaly continues its relentless expansion, and deep within our planet's core, forces are stirring in ways that defy conventional understanding. The timing isn't just remarkable, it's mathematically improbable. As Three-Eye Atlas reaches its closest point to the Sun today, Earth's protective magnetic bubble shows signs of accelerating collapse. Scientists insist these events share nothing more than coincidence. But when you examine the data closely, patterns emerge that challenge everything we thought we knew about planetary stability. If this convergence of cosmic and terrestrial phenomena has captured your attention the way it has mine, hit that subscribe button and ring the notification bell so you never miss an update as this story develops. Drop a comment telling me where you're watching from and what time it is in your location. Share your thoughts on whether we're witnessing random chance or something more deliberate. Today marks a pivotal moment in our planet's history, though most people remain completely unaware of what's transpiring. As Three-Eye Atlas completes its journey around the Sun at precisely 11:47 Coordinated Universal Time, Earth's magnetic field measurements from monitoring stations worldwide paint a disturbing picture. Since 1840, our planet's magnetic dipole moment has declined by approximately 9%. That figure might seem gradual until you grasp what it represents. We're discussing the deterioration of the force field that prevents solar wind from stripping away our atmosphere. The same process that transformed Mars from a potentially habitable world into a barren wasteland. The decline isn't uniform across our planet's surface. Certain regions experience magnetic field collapse so severe that satellites passing overhead encounter radiation levels that would have been inconceivable just decades ago. The South Atlantic Anomaly now encompasses nearly 1% of Earth's total surface area, spanning territory roughly equivalent to half of continental Europe. Within this expanding zone, our magnetic shield has thinned to dangerous levels, creating what scientists describe as a hole in Earth's protective barrier. Meanwhile, Three-Eye Atlas traces its hyperbolic arc through our solar system, originating from somewhere in the galactic neighbourhood we'll never have the opportunity to visit. This marks only the third confirmed interstellar object detected since systematic sky surveys began monitoring for such visitors. The first, 1Anae Oumuamua, baffled researchers in 2017 with its unusual acceleration and elongated shape. The second, 2I Borisov, provided a more conventional example of what astronomers expected an interstellar comet to resemble when it arrived in 2019. Three-Eye Atlas was identified on July 1, 2025 by the Asteroid Terrestrial Impact Last Alert System survey operating in Chile, though analysis of archived images reveals its presence dating back to mid-June. At perihelion today, the object passes approximately 1.36 to 1.4 astronomical units from the Sun, translating to roughly 200 million kilometers. This places it well beyond Earth's orbital path. In December, it will achieve its closest approach to our planet at approximately 1.8 astronomical units, about 270 million kilometers distant. While this presents no collision risk or gravitational disruption, the comet displays unusual characteristics that distinguish it from typical solar system objects. The communities studying geomagnetic phenomena and those tracking interstellar objects rarely interact professionally. Geophysicists focus their attention on convection patterns in molten iron, located 3,000 kilometers beneath our feet, driven by heat remaining from Earth's formation and ongoing radioactive decay of heavy elements. Astronomers direct their instruments toward faint objects moving against stellar backgrounds, calculating trajectories and analyzing spectral signatures. These scientific disciplines operate in largely separate spheres of expertise. However, timing has a way of creating unexpected connections. When your planet's protective magnetic shield develops alarming weak spots at the precise moment an object from beyond your solar system makes its closest approach to your star, even the most rational minds begin questioning whether this represents mere coincidence. The European Space Agency's Swarm satellite constellation has been mapping Earth's magnetic field with unprecedented precision since 2013. The data collected by this mission reveals conditions that contradict comfortable assumptions about geomagnetic changes occurring over centuries or millennia. Since 2020, specific regions have demonstrated accelerated weakening patterns that exceed model predictions. A secondary magnetic minimum beneath southwest Africa emerged and expanded faster than theoretical frameworks anticipated. The North Magnetic Pole, which historically drifted slowly across the Canadian Arctic, has been racing towards Siberia at velocities that required emergency updates to navigation systems. The World Magnetic Model, utilised by everything from smartphone compasses to aircraft navigation equipment, needed an unscheduled correction in 2019 because the pole was moving too rapidly for standard update cycles to maintain accuracy. This investigation will guide you through data that doesn't accommodate comfortable assumptions. We'll examine what's actually occurring with Earth's magnetic field using measurements from satellites, ground stations, and centuries of navigation records. We'll analyse 3i Atlas in comprehensive detail, from its discovery through its unusual polarimetric signatures to the documented anomalies that have prompted some researchers to raise questions about conventional interpretations. We'll explore why mainstream geophysics maintains there can be no connection between a passing comet and core dynamics. Then we'll pose more challenging questions about mechanisms we might not have considered, asking whether the core exists in some kind of threshold state, where minimal perturbations could have disproportionate effects compared to what energy calculations would suggest. Later sections will venture into speculative territory, clearly identified as such. We'll examine fringe theories and conspiracy discussions, not to validate them, but to understand why they emerge when faced with unexplained acceleration in magnetic field decay, coinciding with an interstellar visitor's arrival. Human pattern-seeking minds naturally connect seemingly related events, and some of those connections form pictures that don't survive scientific scrutiny, while others might hint at questions worth investigating, even if we currently lack instruments sensitive enough to test them properly. The boundary between open-minded inquiry and unfounded speculation can become blurred, but we'll attempt to maintain grounding in established science while allowing our investigation to explore genuine possibilities. If 3i Atlas poses no threat, representing merely a chunk of ice and rock following gravitational laws through empty space, then something else must explain why Earth's magnetic field behaves like a system under unprecedented stress. The core doesn't respond to comets in any conventional understanding. Convection patterns in molten metal don't react to gravitational waves from objects barely more massive than mountains passing at astronomical distances. Physics demands identifiable mechanisms, not coincidental timing. Yet physics also demands we examine what's actually happening, even when observations don't align with comfortable narratives. Consider the mathematical improbability of this timing. Earth's magnetic field has been weakening for nearly 2 centuries, with the process accelerating significantly over the past decade. The South Atlantic Anomaly has doubled in area since 2000, expanding from primarily oceanic coverage to include substantial portions of South America and Africa. Magnetic field strength within the anomaly's core has decreased by approximately 25% in some measurements. Satellite operators now routinely factor increased radiation exposure into mission planning when designing orbits and scheduling operations. The European Space Agency's Swarm mission was specifically designed to map these changes in high resolution, and the 3-satellite constellation measures field strength and direction with unprecedented precision, revealing structures and dynamics invisible to ground-based observations. The rate of change matters as much as the magnitude itself. Geologists studying ancient lava flows and sediments can reconstruct Earth's magnetic field behavior over millions of years. This paleomagnetic record shows the field reverses polarity every few 100,000 years on average, though timing patterns remain irregular. Between reversals, the field typically wanders and weakens while generally maintaining its protective structure. What distinguishes current weakening is the rapidity of change in localized regions. The decades-long acceleration in the South Atlantic Anomaly's expansion doesn't match the gradual drift seen throughout most of the paleomagnetic record. Some researchers characterize parts of the current field as changing more rapidly than at any time in the past millennium. Navigation systems worldwide depend on accurate magnetic field models for proper functioning. The World Magnetic Model provides data to aviation navigation systems, maritime compass corrections, military targeting systems, and GPS-assisted compass applications in consumer devices. When the model falls out of synchronization with reality, errors accumulate progressively. Aircraft flying polar routes are particularly sensitive to magnetic declination errors because GPS coverage becomes unreliable near the poles, making magnetic compasses essential backup navigation tools. The 2019 emergency update to the World Magnetic Model was unusual but necessary to prevent potentially dangerous navigation errors. The 2025 update incorporates even more substantial corrections, reflecting a magnetic field that continues evolving faster than 5-year update cycles can adequately track. Predicting the field's future evolution encounters fundamental limitations inherent in chaotic systems. The geodynamo represents mathematical chaos in the technical sense, where small changes in initial conditions or boundary parameters can produce dramatically different outcomes over time. Researchers operate computer simulations of core convection, constrained by observations of current field structure and evolution patterns. These models successfully reproduce some features of secular variation, but struggle with rapid regional changes like the South Atlantic Anomaly expansion. The underlying physics is well understood in principle, but computationally intractable in practice. Simulating turbulent flow in a rotating sphere of electrically conductive fluid at the temperatures and pressures found in Earth's core requires supercomputers running for months to model decades of evolution, and even then the results represent approximations of reality. The emotional impact of this situation isn't lost on researchers who dedicate their careers to studying planetary magnetic fields. This isn't slow geological drift playing out over timescales that make human lifespans irrelevant. Portions of Earth's protective shield are weakening and restructuring right now, during our lifetimes, in ways that could significantly impact our technology-dependent civilization. Satellite operators express concern because of radiation exposure issues. Aviation authorities worry about navigation reliability. But on a deeper level, we're observing a planetary-scale system that has sustained life for billions of years entering a phase that doesn't match comfortable assumptions about stability and predictability. Whether this phase leads to complete polarity reversal, settles into some new configuration, or represents temporary fluctuation that will reverse in coming centuries remains unknown. The data demonstrates change accelerating beyond previous expectations, and we're experiencing this transformation whether we understand it completely or not. Could external forces influence this process? Could variations in solar wind pressure, cosmic ray flux, or hypothetically the passage of an interstellar object somehow couple to core dynamics in ways standard models ignore? Mainstream geophysics categorically rejects these possibilities. The energy scales don't align. The mechanisms don't exist in peer-reviewed literature. But we'll explore these questions anyway because sometimes the most significant scientific advances occur when observations force us to reconsider what we previously thought impossible. For now, simply consider that Earth's magnetic field is exhibiting unprecedented behavior, and scientists are working intensively to understand the implications for the planet we call home. The coincidence of timing with 3I Atlas remains mathematically striking, even if causation seems physically implausible. The story of 3I Atlas begins with its discovery, but understanding its significance requires examining what makes interstellar objects so extraordinary. These cosmic wanderers don't announce themselves with fanfare. They appear as faint dots moving against background stars, distinguished from asteroids and comets only through orbital calculations revealing hyperbolic trajectories that indicate they're passing through rather than orbiting our Sun. When the Asteroid Terrestrial Impact Last Alert System flagged an unusual object on July 1, 2025, astronomers initially processed it as another routine detection. Pre-discovery images extending back to mid-June required careful analysis before the startling realization emerged. The numbers were unmistakable. This object originated from beyond our solar system, making it only the third such visitor we've ever caught in the act of passing through our cosmic neighborhood. The designation C2025S1 tells its story for those who understand astronomical nomenclature. The C indicates a comet with a long period or non-periodic orbit. The Roman numeral 3 prefix marks it as the third interstellar object catalogued by the Minor Planet Center, following 1I Oumuamua's controversial visit in 2017 and 2I Borisov's more conventional appearance in 2019. 3I Atlas occupies a middle ground between these previous visitors. It's definitely exhibiting cometary behavior, showing both a coma and tail as it approaches perihelion. However, it's displaying characteristics that don't perfectly match standard templates. Perihelion timing creates the foundation of our investigation. At exactly 11:47 UTC on October 29, 2025, 3I Atlas reaches its closest point to the Sun at approximately 1.36 to 1.4 astronomical units, roughly 200 to 210 million kilometers away. For perspective, Earth orbits at precisely 1 astronomical unit, so 3I Atlas passes well outside our orbital path. The comet's hyperbolic trajectory means it's travelling faster than solar escape velocity. Gravity from the Sun bends its path but cannot capture it into a bound orbit. After perihelion, 3I Atlas will swing back toward interstellar space, never to return to our solar system. In December 2025, it achieves its closest approach to Earth at roughly 1.8 astronomical units, approximately 270 million kilometers distant. That's more than 700 times farther than the Moon's distance from Earth. No collision risk exists, nor any gravitational perturbation of Earth's orbit. This represents simply a flyby opportunity for scientific observation. Physical characteristics emerge through telescopic observations and spectroscopic analysis. Size estimates suggest a nucleus possibly reaching 5.6 kilometers in diameter. That's larger than many short-period comets within our solar system, though not unusually so by cosmic standards. The nucleus is surrounded by a coma, the cloud of gas and dust produced when solar heating sublimates ice from the surface. Water and hydroxyl radical emission lines appear in spectra, confirming that 3I Atlas carries water ice similar to comets, originating within the solar system. However, here's where the situation becomes intriguing. 3I Atlas began showing significant water emission when it was still beyond 3 astronomical units from the Sun. That's considerably farther out than most solar system comets become active. This early activity suggests either an extremely volatile-rich composition or some mechanism heating the nucleus more efficiently than standard models predict. The implications are significant because they indicate fundamental differences in either composition or behavior compared to familiar cometary objects. Polarimetric observations add another layer of complexity to 3I Atlas's profile. When light reflects off dust particles in a comet's coma, the reflected light becomes polarized. The degree and direction of polarization depend on the size, shape, and composition of the dust grains. Astronomers use polarimetry to study comet dust properties without physically sampling the material. 3I Atlas demonstrated a deep negative polarization branch in pre-perihelion measurements, meaning the reflected light was polarized in ways that don't match typical solar system comets. This specific pattern suggests unusual dust grain properties, possibly indicating different formation conditions in whatever stellar system ejected 3I Atlas billions of years ago. Photometric monitoring, tracking brightness changes over time, reveals temporal variations in dust production patterns. The Nordic Optical Telescope contributed observations showing how 3I Atlas's brightness and tail morphology evolved as it approached the Sun. The tail structure includes both a dust tail swept backward by solar radiation pressure and an ion tail shaped by the solar wind's magnetic field. At various points, observers noted the tail exhibited asymmetries or structures suggesting uneven outgassing from the nucleus. Comets frequently display this behavior as rotating nuclei expose different active regions to sunlight at different times, creating jets and fans of material that give the coma and tail irregular appearances. However, the specific details of 3I Atlas's tail behavior have prompted enough comments in observer reports to merit attention as something worth continued monitoring. Comparative context helps frame what makes 3I Atlas scientifically valuable. Oumuamua confused everyone by showing non-gravitational acceleration without obvious signs of outgassing. Its elongated shape and tumbling rotation were unlike anything previously observed. Proposals range from exotic ices to hydrogen icebergs to one notable but non-mainstream paper suggesting an artificial light sail. 2I Borisov, by contrast, looked exactly like astronomers expected an interstellar comet to appear. It displayed a normal coma, normal dust production, and normal composition. It fit existing models perfectly. 3I Atlas occupies middle ground between these extremes. It's definitely a comet, proven by its coma and tail. But the early water activity, polarimetric oddities, and detailed tail morphology all suggest it's not quite a standard example of comets we're accustomed to studying. Each interstellar object expands our understanding of what constitutes normal behavior, teaching us that planetary systems form objects across a wider range of properties than our single system sample originally suggested. Perihelion could trigger additional surprises as 3I Atlas heats up during closest approach. Sublimation rates spike dramatically near the Sun. Comet nuclei sometimes fragment near perihelion when thermal stress cracks them apart. 3I Atlas's size makes catastrophic breakup less likely, but localized fragmentation or sudden increases in outgassing remain possible. Brightness could spike if fresh ice becomes exposed to direct sunlight. The tail could develop new structures, or alternatively, nothing dramatic might occur. 3I Atlas could simply brighten and become dustier in ways entirely consistent with established comet physics. Observers worldwide are monitoring the situation, telescopes pointed and spectrographs ready to capture whatever happens during this critical phase. Recent analysis has flagged 8 unusual aspects of 3I Atlas's trajectory and behavior. These include alignment angles that appear statistically improbable, the early activity already mentioned, polarimetric anomalies also discussed, and several other technical points that prompt astronomers to comment that something seems odd without necessarily indicating anything revolutionary. Anomalies accumulate in scientific data analysis. Most resolve into measurement errors or incomplete models. A few become seeds of new understanding. Currently, 3I Atlas's anomalies exist in that uncertain zone, where they're interesting enough to mention but not definitive enough to overturn established theories. What 3I Atlas definitely isn't is a threat to Earth. The orbital path doesn't intersect Earth's trajectory. The mass is far too small to gravitationally perturb planetary orbits in any measurable way. This represents an observational opportunity, not a hazard scenario. But opportunities generate questions. What can 3I Atlas reveal about the stellar system it originated from? What does its composition tell us about planet formation conditions in that distant system? How common are interstellar objects in our galactic neighborhood? And for the purposes of our investigation, is there any conceivable mechanism by which its passage could interact with Earth's magnetosphere or deeper planetary systems? Mainstream science provides a definitive answer of no. But we're going to examine that question anyway because the timing remains too mathematically precise to ignore completely. Sometimes the universe displays a sense of irony, darker than we're prepared to acknowledge. The fundamental challenge in connecting 3I Atlas to Earth's magnetic field changes lies in understanding the geodynamo itself. This system generates Earth's magnetic field through processes that sound simple until you attempt to model them mathematically. Liquid iron in the outer core convects, driven by heat escaping from the solid inner core and residual thermal energy from Earth's formation billions of years ago. The liquid iron is electrically conductive. As it flows in complex patterns, it carries magnetic field lines along with it, stretching and twisting them in ways that amplify weak seed fields into the strong dipole structure we observe and depend upon. Earth's rotation adds another layer of complexity, organizing the flow into helical patterns that have sustained the magnetic field for billions of years. The energy source is thermal and gravitational in nature. Timescales range from decades to millennia for secular variation, extending to much longer periods for complete polarity reversals. Nothing about this process, as understood by contemporary geophysicists, invites or allows external triggers from asteroids, comets, or other passing objects. The energy mismatch alone eliminates most proposals for external influence. 3I Atlas possesses a mass measured in trillions of kilograms, which sounds impressive until compared to Earth's mass of nearly 6 times 10 to the 24th power kilograms. The gravitational interaction between them is negligible beyond tidal effects so small they're unmeasurable with current instruments. Even if 3I Atlas passed much closer, perhaps inside the Moon's orbit, its gravitational influence on Earth's core would remain vastly smaller than tidal effects from the Moon and Sun themselves, which are already too weak to significantly affect core convection on human timescales. The electromagnetic energy potentially contained in 3I Atlas's ionized tail, assuming it develops one through interaction with solar wind, represents trivially small amounts compared to the energy budget of the geodynamo. There's no known mechanism to transfer that energy downward through 3,000 kilometers of solid mantle to reach depths where it might theoretically matter. peer-reviewed literature on geomagnetic secular variation doesn't mention comets or asteroids as forcing factors anywhere in thousands of published papers. These studies model core convection, secular variation, polarity reversals, and anomalies like the South Atlantic Anomaly through internal dynamics alone. They invoke thermal convection, compositional convection from solidification at the inner core boundary, and interactions between the core and lower mantle. External factors occasionally considered include Earth's rotation rate, which changes gradually over long timescales due to tidal friction with the Moon. However, these changes are gradual and well constrained within acceptable parameters. Nobody has published a credible mechanism by which a comet passing at 1.4 astronomical units could influence core dynamics in any measurable way. The temporal mismatch reinforces this disconnection between cosmic and terrestrial phenomena. Magnetic pole decline has been ongoing since at least 1840, possibly extending much further back in geological time. The South Atlantic Anomaly's growth accelerated around 2014, more than a decade before 3I Atlas was even discovered by astronomical surveys. The North Magnetic Pole's acceleration towards Siberia began even earlier, in the 1990s. These represent ongoing processes with roots in core dynamics that predate 3I Atlas's arrival by years to centuries. Meanwhile, 3I Atlas's perihelion passage is instantaneous by comparison, lasting mere hours at closest approach. Even if some hypothetical coupling mechanism existed, why would a transient event produce effects that started years earlier and will presumably continue years after the comet departs? Model-based forecasts of magnetic field evolution, including the World Magnetic Model and the International Geomagnetic Reference Field, assume only Earth internal sources drive changes. These models combine current field measurements from satellites and ground stations with decades of historical data, then extrapolate forward using mathematical representations of the field as spherical harmonics. The extrapolation process works adequately for navigation purposes over 5-year update cycles, though rapid changes require occasional corrections between scheduled updates. Crucially, no terms in these mathematical models account for astrophysical events. The equations don't include comet passages, solar wind variations, or cosmic ray flux modifications. They assume the field evolves according to internal processes alone, and this assumption has held up under rigorous testing. Uncertainties certainly exist within our current understanding. Scientists readily acknowledge that physics at the core mantle boundary remains less understood than ideal. This boundary lies 3,000 kilometers beneath the surface, completely inaccessible to direct sampling, observable only through seismic waves and magnetic field measurements detected at the surface. Heterogeneities in the lower mantle affect heat flow patterns from the core in complex ways. The mantle isn't uniform throughout its volume. It contains regions of denser material, variations in thermal conductivity, and residual effects from ancient tectonic events spanning billions of years. These boundary conditions influence core convection in ways that prove difficult to model with complete precision. The appearance of reversed flux patches beneath the South Atlantic and Africa suggests localized core flow patterns that weren't anticipated by earlier theoretical frameworks. Current models are improving steadily, but they remain approximations of a system too complex for complete simulation, using available computational resources. The mainstream scientific perspective maintains that correlation doesn't equal causation in any rigorous sense. Two phenomena happening simultaneously don't necessarily influence each other through direct physical mechanisms. Earth's magnetic field weakens due to internal reasons rooted in core dynamics. 3I Atlas passes through the inner solar system because gravity and momentum carried it here from interstellar space. The overlap in timing might appear striking to pattern-seeking human minds, but it's ultimately meaningless from a physics standpoint. Scientists receive training to resist pattern-seeking behaviors when proposed mechanisms don't support suggested connections. Extraordinary claims require extraordinary evidence, and currently there's no ordinary evidence, much less extraordinary proof, that 3I Atlas affects Earth's core in any way. However, the scientific story doesn't conclude there entirely. Mainstream consensus represents powerful analytical thinking and proves correct in most cases, but it's not infallible under all circumstances. Science advances when observations don't fit existing models, forcing either improved observations or better theoretical frameworks to explain discrepancies. The rapid evolution of the South Atlantic Anomaly surprised researchers precisely because it didn't fit comfortable assumptions about slow secular variation over geological timescales. The detection of 3 interstellar objects in less than a decade, when theory predicted perhaps 1 or 2 per year passing through the inner solar system, suggests our understanding of the local interstellar environment contained gaps. Models represent tools for understanding, not absolute truths about natural processes. They embody our best current understanding, constrained by available data and computational limitations. What if mechanisms exist that we haven't considered? Not because scientists are close-minded, but because observations needed to reveal those mechanisms are recent, subtle, or require instruments we're only now deploying. The geodynamo couples to the mantle through electromagnetic induction and mechanical interactions. The mantle couples to the crust through tectonic forces operating over millions of years. The crust and atmosphere couple through pressure and heat exchange processes. The magnetosphere couples to the upper atmosphere through auroral currents and particle precipitation events. Earth doesn't function as a collection of isolated systems operating independently. It represents a coupled whole with feedback mechanisms operating across vast ranges of timescale and energy. Could some weak coupling exist between heliospheric conditions and deep Earth processes, operating below current detection thresholds but occasionally mattering during threshold states? That question leads into speculative territory that requires careful handling. Before exploring these possibilities, we need to acknowledge the scientific baseline clearly. No known mechanism links 3I Atlas to Earth's magnetic field changes. The energy scales don't match physical requirements. The time scales don't align with observed phenomena. The physics as currently understood provides a definitive negative answer, but science involves asking what-if questions, even when the probable answer is nothing significant. The next phase of our investigation will explore advanced hypotheses, clearly identified as speculative, that attempt to imagine pathways for external influence on core dynamics. Most will fail under rigorous scrutiny, and that's acceptable. The purpose is thinking clearly about how interconnected systems function, and whether our departmentalized understanding might miss something operating at boundaries between disciplines. If 3I Atlas proves harmless, which remains the most likely outcome, then Earth's magnetic field changes have purely internal causes that we need to understand more completely. But examining whether external factors could theoretically matter, even hypothetically, represents an exercise worth conducting systematically. Perfect timing creates psychological unease in human observers. We evolved as pattern-seeking organisms who survived by noticing when environmental changes correlated with potential dangers, even when most apparent patterns represented random noise rather than genuine threats. Evolution didn't reward skeptics who waited for mechanistic explanations before reacting to perceived dangers. It rewarded those who assumed connections existed and acted accordingly, even when wrong. This survival instinct serves us poorly in the contemporary era of massive datasets, where coincidences become statistically inevitable, and our brains continue signaling significance at every apparent alignment of random events. Earth's magnetic field weakening while an interstellar comet makes its closest solar approach feels meaningful at an emotional level. The critical question is whether that feeling points towards something genuine or merely reveals our cognitive biases. Let's explore hypothetical scenarios, clearly marked so nobody mistakes speculation for established scientific fact. Could transient charged particle flux from an interstellar visitor alter near-Earth magnetospheric currents in measurable ways? In principle, any plasma injected into the heliosphere interacts with solar wind and Earth's magnetosphere through well-understood electromagnetic processes. Comets produce ion tails when solar ultraviolet radiation ionizes gases in their expanding comas. The solar wind's magnetic field then drags those ions away from the Sun, creating the characteristic straight tail visible in photographs. If 3I Atlas produces an unusually dense ion tail due to high outgassing rates during its active phase, that tail becomes a temporary feature of local heliospheric plasma conditions. Earth's magnetosphere constantly interacts with solar wind through dynamic processes. It's shaped by that interaction, forming a teardrop configuration with a bow shock on the sunward side and an extended magnetotail streaming away on the night side. Could 3I Atlas's ion tail, if Earth passed through or near it, perturb magnetospheric currents in detectable ways? The answer depends critically on density and geometric factors, Earth won't pass through 3I Atlas's tail in any direct sense. The closest approach occurs at 1.8 astronomical units in December, far too distant for direct tail interaction. However, heliospheric plasma doesn't remain confined to narrow streams indefinitely. It diffuses and mixes turbulently over time and distance. If 3I Atlas injects ions and dust into the solar wind at rates significantly above background levels, those particles spread through volumes that could, in principle, include Earth's magnetospheric environment weeks or months after initial injection. The perturbation would be minimal compared to natural solar wind variability from coronal holes and coronal mass ejections, which dwarf anything a comet could produce. But we're asking about threshold effects, about whether small inputs can just matter when a system is primed to respond disproportionately. Another speculative angle involves cosmic ray modulation. Galactic cosmic rays represent high-energy particles, mostly protons, that permeate the entire galaxy. They're partially deflected by solar wind, creating modulation patterns that depend on solar activity cycles. Earth's magnetic field provides additional shielding, especially at low latitudes where field lines concentrate. If 3I Atlas carried an unusually strong magnetic field embedded in its nucleus or coma, could it locally alter cosmic ray flux in its vicinity? Could such perturbations propagate through the heliosphere and modify ionization rates in Earth's upper atmosphere? The energy scales appear completely wrong for this scenario. Interstellar objects aren't magnetized at levels that would matter across astronomical distances, but stranger proposals have emerged in scientific literature. Oumuamua's non-gravitational acceleration spawned numerous competing hypotheses, some more credible than others. 3I Atlas's early activity and polarimetric oddities at least leave room for unconventional questions. Magnetospheric currents do couple to the ionosphere through well-established electromagnetic processes, and the ionosphere couples to the thermosphere, which couples to atmospheric dynamics, which connect to surface climate and ocean circulation patterns. Everything connects to everything else through chains of influence that weaken with each successive link. The fundamental question is whether any causal chain runs from interstellar comet to deep Earth processes in ways that remain physically plausible. Mainstream geophysics answers negatively because attenuation factors at each step reduce hypothetical influence to insignificance long before reaching the core level. But systems approaching critical points can exhibit disproportionate responses to small forcing mechanisms. Climate tipping points operate through this principle. Ice albedo feedback means small initial warming can trigger runaway ice loss through positive feedback loops. Ecosystem collapses can be triggered by perturbations that wouldn't matter under more stable configurations. Is Earth's geodynamo currently in a threshold state where small perturbations could matter more than energy budget calculations suggest? The accelerating weakening of the South Atlantic Anomaly and rapid pole drift indicate the field exists in a dynamically active phase. Some researchers describe the current configuration as potentially precursory to polarity reversal, though timescales for such events span thousands of years and remain fundamentally unpredictable. Reversed flux patches at the core mantle boundary indicate localized regions where field structure has broken down completely. If core flow is organized into competing systems, with one system weakening the dipole while another attempts to sustain it, then the balance could be more delicate than simple energy, arguments suggest. Small perturbations to boundary conditions, whether from mantle heterogeneity or external electromagnetic forcing, might tip the balance more dramatically than energy budget calculations predict. This represents the boundary where physics slides into informed speculation rather than established science. No peer-reviewed mechanism exists for comet-induced geomagnetic variability in any reputable scientific journal. Proposing such mechanisms requires either discovering completely new physics or identifying overlooked couplings within known physical principles. The latter approach seems more plausible, but it remains a significant long-shot even under optimistic assumptions. Could variations in magnetospheric currents, driven by unusual solar wind conditions or hypothetically by ion injection from a passing comet, induce electric currents in the mantle that somehow feed back to core convection processes? The mantle functions as a poor electrical conductor, but it's not a complete insulator under all conditions. Geomagnetically induced currents from solar storms have been measured at Earth's surface, flowing through ground materials and affecting power grid operations during severe space weather events. Those currents are driven by rapid changes in the magnetosphere during geomagnetic storms, when solar wind conditions become extreme. Could sustained low-level variations in magnetospheric topology from extended interaction with comet plasma produce weak but persistent induced currents deeper within the mantle? The energy budget still doesn't close properly under this scenario. Currents induced in the mantle by magnetospheric variations are many orders of magnitude weaker than currents driving the geodynamo itself. Even if you could somehow couple them to core flow patterns, the effect would be lost in the noise of thermal convection and compositional buoyancy forces that dominate core dynamics. But maybe this represents thinking about the problem incorrectly. Maybe the question isn't whether external forcing adds significant energy, but whether it adds information that matters. A small signal at precisely the right frequency might phase-lock oscillations that are already present within the system, amplifying existing instabilities without adding substantial energy. Analogies exist throughout engineering, such as how small periodic forcing can drive resonance in mechanical systems, producing large amplitude responses from minimal energy input. Whether anything similar applies to geodynamo physics remains unknown because nobody has investigated it seriously. Why would they? The premise seems absurd until you're confronting a timeline where magnetic anomalies accelerate just as an interstellar visitor arrives in your solar system. Conspiratorial thinking thrives in the spaces between observation and explanation. When official statements declare no connection exists, but timing screams otherwise, people naturally fill the void with narratives that make emotional sense. Some claim classified satellite data exists showing electromagnetic interactions between 3I Atlas and Earth's magnetosphere that haven't been publicly released. Others suggest the comet isn't entirely natural, analysing its trajectory for signs of course corrections that would indicate artificial control. Forum discussions dissect discrepancies between published orbital predictions from different sources, treating every small adjustment as evidence of hidden propulsion systems. These discrepancies do exist, but they reflect normal uncertainties in orbit determination for newly discovered objects. Early observations carry larger error margins that converge as more data accumulates over time. The gap between observation and publication creates fertile ground for speculation to flourish unchecked. When space agencies prioritize resources based on scientific value and mission objectives, silence doesn't indicate cover-up. It indicates that scientists are analyzing data thoroughly before making public statements, a responsible approach that conspiracy thinking interprets as deliberate evasiveness. Magnetic field conspiracies operate along parallel lines. Some claim governments know polarity reversal is imminent and are suppressing information to prevent widespread panic. They point to the South Atlantic Anomaly's expansion as evidence the field is collapsing faster than officially admitted. The fundamental problem with this theory is that magnetic field data isn't classified information. Anyone with magnetometers and access to satellite data archives can verify published measurements independently. Geophysicists worldwide, employed by universities and research institutions across dozens of countries, study secular variation openly through international collaboration. A conspiracy to hide imminent reversal would require coordinating thousands of independent researchers across multiple nations, which strains credibility beyond reasonable limits. Moreover, even if reversal was beginning, the process unfolds over millennia rather than years or decades. There's no immediate danger requiring suppression of information. Other theories invoke exotic military technology, allegedly deploying satellites or ground-based installations that artificially weaken the magnetic field as weapons or experimental electromagnetic propulsion systems. These claims never specify actual mechanisms or provide evidence beyond vague assertions that classified technology always remains decades ahead of public knowledge. While military research programs do exist and some remain classified, the idea that secret technology could significantly perturb a planetary magnetic field generated by molten iron 3,000 kilometers deep requires energy inputs that would be detectable through waste heat signatures, power consumption patterns, or electromagnetic emissions. Physics constrains even the most classified projects within fundamental energy and thermodynamic limits. The reason these theories emerge stems partly from genuine uncertainties that exist within mainstream science. Scientists don't fully understand why the South Atlantic Anomaly expands as rapidly as observed. Current models struggle to predict detailed evolution patterns accurately. When experts acknowledge they don't know something yet, some people interpret this as evidence they're concealing information deliberately. The human mind calibrates poorly for genuine uncertainty about complex natural processes. We evolved to make quick decisions with incomplete information, erring toward false positives because missing real threats proved more dangerous than seeing threats that didn't actually exist. This cognitive heritage makes us susceptible to conspiracy thinking when faced with ambiguous data and complex explanations that don't provide immediate emotional satisfaction. The timing coincidence amplifies everything significantly. If Earth's magnetic field were changing in isolation, it would be concerning but explicable through internal dynamics alone. If 3I Atlas were passing through in isolation, it would be fascinating but unrelated to Earth's welfare. Together, they create a narrative framework that feels inherently meaningful. Our brains are specifically wired to detect agency and intention behind patterns in our environment. When two significant events coincide temporally, we assume connection even when none exists through any known physical mechanism. This represents the same instinct that made our ancestors perceive faces in cloud formations and attribute natural disasters to angry supernatural entities. It's deeply human, and reckon make us immune to it sizing this tendency in ourselves doesn't influence during stressful or uncertain situations. Investigative analysis requires acknowledging these perspectives without validating unfounded conclusions. People speculating online aren't unintelligent. They're responding to genuine strangeness in available data using the cognitive tools and information sources available to them. The role of science communication isn't to mock alternative theories, but to provide context that fills knowledge gaps conspiracy theories exploit systematically. Here's what we actually know with confidence. Here's what remains unknown or uncertain. Here's why the explanation you're encountering isn't supported by current evidence. Here's what type of evidence would be needed to change that assessment fundamentally. Transparency and intellectual honesty represent the most effective antidotes to conspiracy thinking, even though they're slower acting and less emotionally satisfying than dramatic revelations. Whether you believe 3I Atlas represents an alien probe or a natural comet, whether you think magnetic field changes are being hidden or openly studied by international scientific collaboration, the underlying questions remain valid and worth investigating. What don't we actually know? What mechanisms might we be overlooking? What observations would change our understanding if they were discovered? Science advances by asking uncomfortable questions even when the answers usually turn out to be that nothing unusual is happening. Because occasionally, rarely, the answer proves different. We can't distinguish those exceptional cases from false alarms without examining data carefully and honestly. The next phase steps back from speculation and controversy to examine what recent scientific developments across multiple fields reveal about planetary magnetic fields, interstellar objects, and the observational tools we're developing to study them. Because regardless of what 3I Atlas does or doesn't do to Earth, the coincidence of their intersection in 2025 has focused attention on phenomena that matter independently of any causal connection. Jupiter's moon system provides compelling comparative examples that illuminate Earth's magnetic situation. Ganymede stands out as the only moon in our solar system known to generate its own magnetic field through internal dynamo processes, making it a miniature analogue of Earth despite being much smaller and colder. Recent data from spacecraft missions through 2025 revealed that Ganymede's magnetic field behaves in ways that challenge theoretical models of how small-body dynamos should function. These anomalies echo in miniature the surprises Earth's magnetic field has delivered, suggesting our understanding of planetary magnetic field generation might need revision across multiple scales of investigation. Ganymede's magnetic field was discovered during Galileo's spacecraft flybys in the 1990s. The field remains weak compared to Earth's, but it's definitely present, creating a mini-magnetosphere embedded within Jupiter's enormous magnetosphere. The source presumably involves a liquid iron core heated by tidal flexing, as Ganymede orbits Jupiter in gravitational resonance with Europa and Io. That tidal heating isn't as extreme as what melts Io's interior into a volcanic hellscape, but it's sufficient to keep portions of Ganymede's core molten and convecting. Convection plus rotation plus electrical conductivity should equal dynamo action, at least according to standard theory. Models predicted the field should remain relatively stable over timescales shorter than centuries, since the Moon's thermal and orbital evolution represent slow processes. Recent analysis of magnetometer data from the Juno spacecraft, which has conducted close flybys of Ganymede while studying Jupiter, revealed temporal variations in the Moon's magnetic field that weren't anticipated. The field strength appears to fluctuate over timescales of months to years, not dramatically, but enough to be detectable above measurement uncertainty. These fluctuations suggest the internal dynamo isn't as stable as simple models predicted. Perhaps core convection patterns are more turbulent than expected, or perhaps boundary conditions at the core-mantle interface are more heterogeneous than assumed. Either way, Ganymede's magnetic field demonstrates that even small bodies can exhibit complex dynamo-dynamics that exceed theoretical predictions. Europa presents a different puzzle entirely. It doesn't possess an internal dynamo, but it does generate an induced magnetic field created by Jupiter's time-varying magnetic field, sweeping through Europa's electrically conductive subsurface ocean. The ocean spans tens of kilometers ice shell above and rocky man in depth, sandwiched between Antle below, maintained in liquid state by tidal heating processes. As Jupiter's magnetic field varies with the planet's rotation and Europa's orbital motion, it induces electrical currents in the salty ocean, which generates secondary magnetic fields measurable by spacecraft instruments. Detailed measurements of these induced fields constrain ocean depth, salinity levels, and thickness of the overlying ice shell with remarkable precision. Recent data showed asymmetries in the induced field, suggesting ocean properties vary with geographic location, possibly indicating regional differences in heat flow or ice thickness that weren't predicted by uniform models. Why do these icy moon magnetic anomalies matter for Earth's story? Because they demonstrate that planetary magnetic fields, whether generated internally or induced externally, prove more dynamic and complex than simplified theoretical models suggest. Earth's magnetic field isn't unique in showing unexpected variations beyond model predictions. Ganymede's dynamo fluctuates unpredictably. Europa's induced field exhibits asymmetries that require explanation. Even small bodies with simpler physics than Earth display behaviors requiring updated models to explain adequately. This pattern suggests our understanding of magnetic field generation and evolution remains incomplete across all scales, not just for Earth-sized planetary bodies. The comparison raises intriguing questions about internal structure and dynamics. If Ganymede's core proves more turbulent than expected, could Earth's core also harbour dynamics that aren't captured in current numerical simulations? Both bodies generate magnetic fields through liquid metal convection, though scales and driving mechanisms differ substantially. Ganymede's tidal heating concentrates energy input in specific ways, potentially creating heterogeneous boundary conditions that affect flow patterns in unexpected ways. Earth's core mantle boundary also contains heterogeneities from mantle structure variations revealed through seismic tomography. Could those heterogeneities matter more than current models assume? The South Atlantic Anomaly sits above a region where seismic imaging shows unusual mantle structure, hinting at possible connections between deep mantle properties and core dynamics that warrant further investigation. Europa's ocean-driven induced field offers a different type of analogue for understanding electromagnetic coupling processes. Earth doesn't contain a subsurface ocean like Europa, but it does possess a conducting ocean of molten iron in the outer core, and it exists embedded within the solar wind's varying magnetic field environment. The scales differ vastly, but the fundamental principle of induced fields responding to external variations applies across both systems. Could variations in solar wind pressure or heliospheric magnetic field geometry induce weak secondary fields in Earth's mantle or upper core regions? The electrical conductivity remains much lower than in Europa's salty ocean, but time-varying external fields are definitely present throughout the heliosphere. This connects back to coupling mechanisms explored earlier in our investigation. Europa proves that external magnetic fields can induce measurable responses in conducting layers, at least when conductivity reaches sufficiently high levels. The question becomes whether analogous processes could operate within Earth's internal structure, even at much weaker coupling strengths. Upcoming missions will refine our understanding significantly. The European Space Agency's JUICE mission, launched in 2023, will arrive at Jupiter in 2031 and spend years studying Ganymede, Europa, and Callisto, with advanced magnetometers, radar systems, and other instruments capable of unprecedented measurements. NASA's Europa Clipper, launched in 2024, will arrive in 2030 and conduct detailed measurements of Europa's induced magnetic field, ice shell properties, and ocean characteristics. These missions will provide time series data showing how magnetic fields vary over mission durations, constraining dynamo models and ocean conductivity parameters with far greater precision than currently possible. Whatever they discover will feed back into broader understanding of magnetic field generation processes throughout the solar system and beyond. The thematic parallel to Earth's current situation becomes clear when examined systematically. Planetary magnetic fields continue surprising researchers across multiple scales of investigation. Earth's field weakens and restructures faster than comfortable theoretical expectations. Ganymede's field varies over shorter timescales than models predicted. Europa's induced field exhibits unexpected asymmetries requiring new explanations. Across the solar system, observations consistently outpace theoretical ability to explain them completely. This doesn't indicate that fundamental physics is incorrect. It means our models represent approximations that work well within certain parameter ranges, but fail when pushed into regimes where simplifying assumptions break down. Real planets and moons contain complications that idealized models ignore, and those complications sometimes matter more than anticipated. If Earth's magnetic field behavior represents part of a broader pattern where planetary magnetic fields generally show unexpected dynamics, then perhaps the surprises we're observing are less about specific triggering events and more about fundamental gaps in our understanding of how dynamo systems function under real-world conditions. That perspective is actually reassuring in important ways. It suggests Earth isn't exhibiting uniquely alarming behavior that requires exotic explanations. It's simply doing what magnetic field-generating bodies do throughout the solar system, which proves more complex and dynamic than textbook descriptions indicated. The goal now involves building better theoretical models that capture this complexity more accurately, informed by observations from Earth, Ganymede, and whatever other bodies reveal magnetic surprises as measurement techniques improve. 3I Atlas might remain completely irrelevant to all of these processes, but the coincidence of its arrival during a period when Earth's field surprises us and when other solar system bodies also show magnetic anomalies we didn't predict, at least raises questions about whether we're missing something fundamental about how magnetic fields respond to their environments. Probably not, but the possibility warrants systematic investigation. That maybe justifies continued exploration, which subsequent sections of this investigation will pursue through examination of advanced observational techniques and upcoming missions that might provide definitive answers to questions we're only now learning to formulate properly. The James Webb Space Telescope has revolutionized our understanding of cosmic phenomena since beginning operations, but 2025 brought discoveries that forced astronomers to reconsider fundamental assumptions about planetary atmospheres in ways that echo how 3I Atlas and Earth's magnetic field behavior challenge separate sets of established theories. In mid-2025, observations of an exoplanet designated HD 435b revealed atmospheric spectral signatures that don't match any known formation scenario. The planet represents a hot Jupiter orbiting its host star in under 4 days at temperatures where atmospheric chemistry should be dominated by hydrogen, helium, and simple molecules like water vapor and carbon monoxide. Instead, Webb detected silicon vapor and metallic compounds in concentrations suggesting the atmosphere is being actively replenished by vaporizing surface rock, despite the planet lacking extreme temperatures required for continuous rock vaporization at observed rates. The discovery emerged from transmission spectroscopy, where Webb's infrared instruments measured starlight filtering through the exoplanet's atmosphere during transit events. Absorption features in the resulting spectrum revealed molecular signatures that shouldn't exist in such abundance. Magnesium silicate vapor, iron vapor, aluminum oxide, all present in amounts requiring surface temperatures exceeding 3000 Kelvin. Yet thermal emission measurements from the planet's day side indicated temperatures around 2000 Kelvin, hot enough to melt lead but insufficient to vaporize rock at rates necessary to sustain observed atmospheric abundances. Something about the planet's interior or atmospheric dynamics delivers rock vapor to the atmosphere more efficiently than thermal models predict. Several competing explanations have emerged from the astronomical community. One possibility involves extreme volcanic activity driven by tidal heating beyond what models predicted for this system's orbital configuration. Perhaps the planet's interior is more molten and active than assumed, with massive volcanic eruptions continuously injecting silicate vapor into the atmosphere. Another possibility suggests atmospheric dynamics create localized hotspots where temperatures exceed global averages, concentrating thermal energy sufficiently to vaporize exposed rock surfaces. A third, more exotic proposal suggests the planet's magnetic field, if it possesses one, might channel energy from stellar wind into the atmosphere in ways that create localized heating beyond what stellar irradiation alone provides. That possibility echoes speculative mechanisms discussed regarding 3I Atlas and Earth's magnetic field interactions. Could external energy inputs, channeled through magnetic field interactions, produce effects disproportionate to simple energy budget calculations? In the exoplanet case, stellar wind energy might couple through the magnetosphere to the upper atmosphere, creating electric currents that heat plasma to temperatures exceeding thermal equilibrium predictions. This represents essentially auroral heating scaled to extreme levels. Earth's auroras deposit energy into the upper atmosphere, heating it and driving chemical processes. For a hot Jupiter orbiting extremely close to an active star, the effect could be orders of magnitude stronger, potentially explaining atmospheric chemistry that pure thermal models fail to reproduce. The Nancy Grace Roman Space Telescope, which began as science operations in early 2025, contributed a complementary discovery involving a directly imaged exoplanet around a young star system. The planet, estimated at several Jupiter masses, showed unexpected variability in infrared emission over timescales of hours rather than the days or weeks predicted by atmospheric circulation models. Variability suggests atmospheric dynamics, or surface features, rotating into and out of view as the planet spins. But the amplitude of variation exceeded expectations for a planet at that age and temperature. Models predict young planets should maintain relatively uniform temperatures due to efficient heat redistribution through atmospheric circulation patterns. Strong variability implies either that heat redistribution is less efficient than assumed, or that localized heat sources or reflectivity variations create larger contrasts than theoretical models allow. These discoveries might seem tangentially related to our investigation of 3I Atlas and Earth's magnetic field, but the connection is methodological and philosophical rather than directly physical. In each case, observations reveal behavior that doesn't match straightforward predictions from established models. Earth's magnetic field changes faster than secular variation models predicted. 3I Atlas shows activity and properties that don't fit standard comet templates perfectly. HD 453b exhibits atmospheric chemistry that thermal models don't explain adequately. Roman's directly imaged planet varies more than expected under current theoretical frameworks. The pattern suggests our models, while broadly correct within tested parameter ranges, are missing components that matter under specific conditions. What components might be absent from current understanding? For exoplanets, it could involve magnetic field interactions with stellar winds, tidal heating mechanisms that operate more efficiently than current models allow, or atmospheric dynamics in extreme temperature and pressure regimes that aren't captured by models validated on solar system planets. For Earth's magnetic field, missing components might include heterogeneities at the core mantle boundary that introduce instabilities, or coupling between different timescales of variation that amplify secular trends unexpectedly. For 3I Atlas, gaps could involve compositional differences reflecting formation conditions outside the range sampled by solar system bodies, or surface processing during its long interstellar journey that altered volatile distributions in unusual ways. The broader lesson concerns the limits of theoretical understanding when confronting genuinely complex systems. Models necessarily simplify reality to make calculations tractable. You assume spherical symmetry when objects are actually irregular. You ignore magnetic fields when they might matter. You treat convection as smooth and laminar when it's actually turbulent and chaotic. These simplifications work adequately for many purposes, allowing prediction of orbits, estimation of temperatures, and calculation of basic properties. But they fail when details matter, when systems operate near transitions, or when neglected terms become important under specific circumstances. Science advances by recognizing when models break down and determining what's missing from theoretical frameworks. James Webb and Roman are demonstrating that exoplanet atmospheres are more complex than models based on solar system analogs suggested. That's exciting rather than disappointing because it means new physics remains to be discovered, new regimes of planetary behavior to characterize, new connections between processes we thought were separate. Every surprise represents an opportunity to refine understanding and develop more complete theories. The same principle applies to Earth's magnetic field evolution and interstellar object behavior. Surprises indicate we're pushing into territory where simple models prove insufficient, which means we're learning things that earlier observations couldn't teach us. The pace of discovery is accelerating dramatically. Webb and Roman deliver data faster than theoretical frameworks can absorb completely. Ground-based surveys find interstellar objects at increasing rates as detection methods improve. Satellite constellations map Earth's magnetic field with unprecedented spatial and temporal resolution. Each new dataset raises questions requiring new models, new simulations, new theoretical frameworks to explain adequately. The 2020s might be remembered as the decade when observations outran theory across multiple fields simultaneously, forcing scientists to acknowledge that reality is richer and stranger than simplified theoretical pictures suggested. That's uncomfortable for researchers who prefer understanding to precede observation in orderly fashion. But it's thrilling for anyone who appreciates that the universe still holds genuine surprises, that we don't have everything figured out yet, that authentic mystery remains to explore and understand. Whether 3I Atlas affects Earth's magnetic field, whether exoplanet atmospheric anomalies connect to magnetic field physics, or whether these represent entirely separate phenomena, the coincidence of all these surprises occurring within the same few years creates an atmosphere of uncertainty and discovery that defines our current scientific moment. We exist in a phase where instruments are sophisticated enough to detect deviations from predictions, but theoretical understanding hasn't caught up to explain them completely. That gap between observation and explanation is precisely where scientific breakthroughs occur most frequently. Someone will propose new frameworks that unify disparate observations. Others will develop models that capture missing physics more accurately. Researchers will design experiments that test competing hypotheses rigorously. Understanding will advance not smoothly, but through discontinuous jumps triggered by accumulation of unexplained data demanding better explanations. If this investigation carries a message beyond the specific story of 3I Atlas and Earth's magnetic field, it's that we're living through an era where observation is revolutionizing understanding faster than ever before in human history. The tools we've built to study the universe are revealing complexities we never imagined, forcing us to confront the limits of our knowledge while opening new frontiers for exploration. The relationship between 3I Atlas and Earth's magnetic field anomalies may prove entirely coincidental, but the exercise of investigating that relationship seriously has illuminated how much we still don't understand about the systems that sustain life on our planet and the cosmic environment we inhabit. That ignorance isn't a failure of science. It's an invitation to keep pushing the boundaries of knowledge, to keep asking difficult questions, and to remain humble before the vast complexity of the universe we're trying to understand. The investigation continues, and the most profound discoveries may still lie ahead. Artificial intelligence is revolutionizing how we analyze complex data patterns, and nowhere is this transformation more critical than in predicting Earth's magnetic field evolution. Traditional approaches to forecasting geomagnetic changes have relied on physics-based models that simulate core convection through massive computational efforts, but these simulations capture only decades of evolution at best and struggle with the rapid regional changes we're currently observing. Machine learning offers a fundamentally different approach to this challenge. Instead of simulating physics from first principles, AI systems treat magnetic field prediction as a pattern recognition problem. Train a neural network on decades of satellite and ground-based magnetic field measurements. Feed it historical data showing how the field evolved over time. Let the system learn correlations between current field configurations and future changes, then ask it to predict what comes next based on today's measurements. Early results proved remarkably promising. Machine learning models trained on magnetic field data from 1980 to 2010 successfully predicted secular variation trends through 2020 with accuracy comparable to traditional physics-based models. This achievement is particularly impressive because these AI systems don't understand anything about core convection or dynamo theory. They operate purely through statistical pattern recognition, suggesting the data contains predictive structure that can be extracted without explicit physical understanding. However, a significant limitation emerges with this approach. Machine learning models function as sophisticated interpolators, performing well within the range of conditions they encountered during training. When conditions shift outside that training distribution, predictions become unreliable. The current rapid changes in the South Atlantic Anomaly might represent exactly such a shift, potentially causing AI predictions to fail precisely when they're most needed. More sophisticated hybrid approaches combine physics-based understanding with machine learning capabilities. These systems use neural networks to parameterize processes that are computationally expensive to simulate directly, such as turbulent diffusion or heat transport at the core mantle boundary. The overall simulation remains grounded in physical equations, but certain terms are replaced with learned functions that approximate their behavior more efficiently. This hybrid methodology allows simulations to run faster, while exploring parameter space and quantifying uncertainties that would be impossible with pure physics simulations. Results from hybrid models in 2024 agreement with observations compare, and 2025 showed improved to earlier purely theoretical simulations, suggesting this approach captures important physics that fully parameterized models missed entirely. Could artificial intelligence detect patterns in geomagnetic data that hint at external forcing mechanisms? This question ventures into speculative territory, but the potential implications warrant serious consideration. If weak correlations exist between solar activity, cosmic ray flux, or hypothetically comet passages and geomagnetic secular variation, machine learning models might detect them even when the physical mechanisms remain unknown. You could train models on magnetic field data alongside solar wind parameters, sunspot numbers, galactic cosmic ray flux measurements, and whatever other external variables you hypothesize might influence Earth's magnetic field. If the model's predictions improve when those variables are included, that suggests correlations worth investigating further. If predictions don't improve, the correlations either don't exist or are too weak to matter practically. No published studies have found significant correlations between space weather and core dynamics on secular variation timescales. Solar cycle variations affect the ionosphere and magnetosphere, but don't appear to penetrate to core levels. This matches theoretical expectations based on energy scaling arguments, but machine learning approaches might prove sensitive enough to detect weak correlations that traditional statistical tests miss, especially if relationships are nonlinear or involve time delays that obscure direct correlation analysis. The computational cost of testing these hypotheses remains relatively low compared to potential payoffs of discovering unexpected coupling mechanisms. One major challenge involves distinguishing genuine correlation from spurious patterns. Machine learning models can find coincidental correlations in noisy data, fitting patterns that are statistically significant but physically meaningless. Rigorous validation requires testing predictions on independent data not used during training, and ideally having plausible physical mechanisms to explain any correlations discovered. If a model predicts that geomagnetic jerks correlate with solar wind pressure variations 3 years prior, but nobody can explain why such a correlation would exist physically, it's probably spurious rather than meaningful. Another promising application involves predicting magnetic anomalies before they fully develop. The South Atlantic Anomaly's rapid growth surprised researchers partly because existing models didn't anticipate it adequately. Machine learning systems trained on detailed spatial and temporal patterns might recognize precursors to anomaly formation or growth phases, enabling earlier warnings for satellite operations and space mission planning. Success in this area requires models trained on higher resolution data than used for global dipole predictions, capturing fine-scale structures at the core mantle boundary that seed regional anomalies. AI techniques are also being applied to paleomagnetic data, learning patterns of field evolution over millions of years from records preserved in rocks and sediments. These models attempt to identify precursors to polarity reversals or excursions, potentially revealing whether current field configuration resembles pre-reversal states observed in Earth's geological past. Results remain tentative because paleomagnetic data is inherently noisy and sparse compared to modern satellite measurements. but with sufficiently large datasets and sophisticated algorithms, meaningful patterns might emerge. The philosophical question underlying all of this involves whether artificial intelligence can discover genuinely new physics or merely accelerate application of known physical principles. Most researchers argue for the latter interpretation. Machine learning systems are tools that identify patterns in data, but they don't inherently explain why those patterns exist. Physical understanding still requires human interpretation of discovered patterns and proposal of underlying mechanisms. Nevertheless, AI-accelerated discovery represents a genuine phenomenon. When models point toward unexpected correlations or predict phenomena before they occur, they guide human attention toward fruitful research directions. Even if artificial intelligence doesn't directly reveal physical mechanisms, it can highlight where new mechanisms are needed, which proves valuable in complex systems where intuition alone proves insufficient. For the specific question of whether 3i Atlas could affect Earth's magnetic field, artificial intelligence offers no special insights because the hypothesized coupling remains so weak and available data so limited. You would need simultaneous measurements of comet position, solar wind conditions, magnetospheric state, and core dynamics over many comet passages to train a meaningful model. We possess exactly one data point, which is statistically useless. However, AI techniques applied to Earth's magnetic field evolution, independently of any comet considerations, are already improving predictions and revealing patterns that inform our understanding of dynamo processes. As datasets grow and models become more sophisticated, we'll develop increasingly powerful tools for anticipating how the field evolves, regardless of whether external forcing plays any role. Climate science has taught us that Earth's systems connect in ways that cross traditional disciplinary boundaries, linking processes that appear unrelated at first examination. A groundbreaking study published in late 2024 revealed connections between surface climate changes and deep Earth dynamics that blur the boundaries between atmospheric science and geophysics, demonstrating that Earth's interior isn't as isolated from surface conditions as traditionally assumed. The research focused on geothermal heat flux beneath Antarctic and Greenland ice sheets. Heat escaping from Earth's interior through the crust contributes to basal melting of ice, affecting ice sheet stability and global sea level rise. Previous estimates of geothermal flux relied on sparse direct measurements and models based on crustal age and composition. The new research combined seismic tomography, revealing mantle structure beneath ice sheets with improved models of heat transport through crustal rocks. Results showed that geothermal flux varies more dramatically than earlier estimates suggested, with some regions beneath Antarctica experiencing heat flux double the global average, concentrated where mantle plumes or remnants of ancient rifting bring hot material closer to the surface. Consider what happens when massive ice sheets melt rapidly. The weight of ice depresses the underlying crust through a process called isostatic loading. When ice melts, the crust rebounds over thousands of years as mantle material flows laterally to restore gravitational equilibrium. This redistribution of mass and pressure alters stress patterns in the crust and upper mantle, potentially affecting how heat flows from deeper regions. Additionally, removing several kilometers of ice changes thermal boundary conditions at the surface. Ice insulates the crust beneath it, and when it melts, the crust can cool or warm depending on ocean or atmospheric conditions, replacing the ice cover. These temperature changes propagate downwards slowly, taking thousands to millions of years to reach significant depths, but they do propagate through the system. Could rapid ice loss from Greenland and Antarctica, accelerating over recent decades, affect deep Earth processes on timescales relevant to human civilization? Traditional analysis suggests no, because timescales are fundamentally mismatched. Ice mass changes occur over decades to centuries, while mantle convection operates over millions of years and core convection over decades to millennia for secular variation. The energies and momentum involved in ice sheet changes also appear dwarfed by anything surface processes could contribute to core dynamics. Yet the 2024 study suggested that for regions where mantle structure is already anomalous, where heat flux concentrates through unusual geological configurations, surface load changes might matter more than simple scaling arguments indicate. The proposed mechanism involves stress redistribution affecting melt pathways or volatile release in the upper mantle, which could alter local heat flux patterns more rapidly than bulk mantle flow timescales would suggest. The connection to magnetic field anomalies remains speculative but intriguing from a systems perspective. If geothermal flux variations at the core mantle boundary contribute to organising core flow patterns, and if surface mass redistribution from ice loss can alter geothermal flux on century timescales in specific regions, then a potential feedback loop connects climate change to geomagnetism. It's not a strong or direct connection, and the energy involved in ice sheet melting remains trivial compared to core convective energy. But if the geodynamo system operates near a threshold, where small perturbations to boundary conditions can tip flow patterns from one configuration to another, then even weak surface forcing might occasionally matter. This logic parallels earlier speculation about hypothetical space weather coupling, applied instead to internal Earth processes with slightly more physical grounding. For our investigation's narrative, the climate-magnetism connection offers an alternative to external forcing that remains speculative but more firmly rooted in established physics than comet core interactions. If Earth's magnetic field is behaving unexpectedly, perhaps it's responding to changes we've induced at the surface through rapid climate modification rather than cosmic influences. Ice sheets are melting faster than any period in the paleoclimate record, except during catastrophic deglaciation events following ice ages. Ocean circulation patterns are shifting in response to freshwater input and temperature changes. Crustal stresses are adjusting as mass redistributes from ice sheets to oceans. These represent real, measurable changes happening on observable timescales. Whether these changes cascade down to core mantle boundary conditions within decades or centuries, and whether such cascades would significantly influence core dynamics, remains to be determined through future research. But it serves as a reminder that Earth's systems interconnect more extensively than disciplinary boundaries typically acknowledge. Understanding how our planet functions requires examining the whole system rather than isolated components studied in academic silos. As we navigate coming decades of rapid environmental change, those connections might prove important in ways we haven't anticipated, revealing that human actions at the surface have consequences deeper and more far-reaching than we currently imagine possible. The intersection of 3I Atlas's passage and Earth's magnetic field evolution in 2025 creates a moment worth documenting regardless of whether any causal connection exists between these phenomena. But this moment represents just one frame in an ongoing story that will unfold over coming years and decades as new instruments become operational, fresh data accumulates, and deeper understanding emerges from continued investigation. Several missions launching or operating through the late 2020s will provide observations that could clarify questions this investigation has raised, testing hypotheses about magnetic field dynamics, interstellar objects, and planetary systems in ways impossible with current technology. Let's examine what's approaching and what to monitor as this story continues developing. For Earth's magnetic field research, the European Space Agency plans a swarm follow-on mission, tentatively scheduled for the early 2030s, continuing high-resolution mapping of field evolution with improved instruments and extended coverage. The current swarm constellation has operated since 2013, providing data that reveal the South Atlantic Anomaly's rapid expansion and the secondary minimum developing under Africa. Extending that time series another decade will prove crucial for distinguishing between secular variation pulses and genuine transitions toward polarity reversal. Satellite magnetometry remains the only method for observing core dynamics, translating field measurements at Earth's surface back to their sources at the core mantle boundary through mathematical inversion techniques. More data means better constraints on core flow patterns and improved predictions of future evolution. For planetary magnetic fields more broadly, the JUICE and Europa Clipper missions will provide detailed monitoring of Jupiter's icy moon magnetospheres throughout the 2030s. JUICE will orbit Ganymede, mapping its intrinsic magnetic field at high resolution over multiple years. That extended time series will reveal whether fluctuations detected in recent data represent persistent features or transient variations, constraining dynamo models for small planetary bodies. Europa Clipper will conduct dozens of flybys through Europa's induced magnetic field, mapping ocean conductivity and ice shell thickness with unprecedented precision. Both missions carry magnetometers and plasma instruments that will characterize Jupiter's magnetosphere and its interactions with moon surfaces and interiors, providing comparative context for understanding Earth's magnetospheric dynamics. These observations will help determine whether magnetic field complexity represents a universal feature of planetary systems or something unique to specific configurations. the Nancy Grace Roman Space Telescope will continue direct imaging of exoplanets, characterizing atmospheric properties and variability patterns that inform models of planet formation and evolution. Roman's coronagraph technology enables detection and spectroscopy of planets at orbital separations, where atmospheric dynamics transition from tidally locked configurations to more Earth-like circulation patterns. Observations throughout the late 2020s will build a comprehensive census of young giant planets, revealing how common magnetic field-driven phenomena like auroral heating might be in explaining atmospheric properties that thermal models alone cannot account for. Every surprise in exoplanet observations challenges assumptions that feed into our understanding of solar system planets, including Earth, creating valuable feedback between different scales of planetary science. Ground-based gravitational wave detectors reached new sensitivity levels in 2025, enabling detection of mergers and other events at greater distances than previously possible. While seemingly unrelated to magnetic fields and comets, gravitational wave astronomy provides increasingly precise tests of general relativity and strong field gravity that constrain fundamental physics. Any deviations from theoretical predictions might hint at new physics that could, in principle, affect how we understand gravity's role in planetary interiors or orbital dynamics. The connections remain tenuous, but high-precision tests of fundamental physics occasionally reveal surprises that cascade across multiple fields of study. What should you monitor in coming years if these topics interest you? First, watch for announcements about Earth's magnetic field evolution. The World Magnetic Model updates every 5 years, with the next version due in 2030. If secular variation accelerates further or new anomalies emerge, that will generate headlines in geophysics communities and should propagate to science media coverage. Second, follow interstellar object detections closely. As the Vera Rubin Observatory becomes operational, discovery rates will increase dramatically. Each new object might reveal properties that challenge or confirm patterns emerging from 3I Atlas, Oumuamua, and Borisov observations. Third, track developments in planetary missions, particularly JUICE and CLIPPER, results in the early 2030s, which could revolutionize understanding of planetary magnetic fields and ocean worlds. Pay attention to AI-driven discoveries in both geophysics and astronomy. Machine learning models are increasingly deployed to analyze large data sets, finding patterns human researchers might overlook. If an AI system predicts a geomagnetic jerk or identifies precursors to magnetic field anomalies, that will validate the approach and potentially provide early warning capabilities for future events. Similarly, machine learning techniques applied to exoplanet data or interstellar object observations might reveal correlations or classifications not recognized through traditional analysis methods. For those hoping 3I Atlas might still provide surprises, the weeks following perihelion on October 29th remain critical for observation. If the nucleus fragments or exhibits unusual outgassing behavior, observers worldwide will be monitoring the situation intensively. Any deviation from expected brightness curves or tail structures will trigger intensive follow-up observations. If nothing unusual occurs, that's equally informative, confirming 3I Atlas as a relatively normal comet despite its interstellar origin. Either outcome teaches us something valuable about how comets behave under perihelion heating conditions and what properties vary between solar system and extrasolar formation environments. The broader message underlying all of this is that science represents an ongoing process rather than a collection of final answers. The questions raised in this investigation won't receive definitive resolution for years, possibly decades. Magnetic field evolution operates on timescales longer than individual careers. Interstellar object studies require building statistics over many detections spanning multiple decades. Understanding planetary systems demands missions that require years to reach their targets and additional years to complete comprehensive observations. This represents normal scientific practice. Patience is required, but genuine progress occurs as understanding advances incrementally through data accumulation and model refinement. The coincidence of 3I Atlas's passage and magnetic field anomalies in 2025 will eventually be viewed within the context of longer-term patterns that clarify whether the timing carried any significance or represented pure statistical chance. If you take nothing else from this journey through magnetic anomalies and interstellar visitors, consider this. Earth proves more dynamic than most people realize. Our solar system exists embedded within a galactic environment that influences planetary processes in ways we're only beginning to map systematically. The universe continues holding mysteries that challenge our most sophisticated understanding. 3. Atlas won't end civilization. Your compass will function normally tomorrow morning, but somewhere 3,000 kilometers beneath your feet, molten iron flows in patterns that might be changing in unprecedented ways. Somewhere beyond Mars's orbit, a visitor from another star system begins its long journey back into the darkness between stars, carrying secrets about worlds we'll never visit. Both stories deserve careful attention, even if they never intersect except through the timing that brought them to our awareness during the same brief moment of cosmic history we happen to occupy. The investigation continues, driven by curiosity about the fundamental processes that govern our planet and our place within the larger universe. Stay curious about the data as it emerges. Watch for patterns that challenge comfortable assumptions. Remember that the most profound discoveries often emerge from questions that seem absurd right until the moment they prove to be exactly the right questions to ask about the nature of reality. The mathematical precision of timing defies comfortable explanation. As October transitions into November 2025, Earth's magnetic field monitoring stations worldwide record accelerating deterioration patterns that correlate with phases of 3I Atlas's solar encounter in ways that stretch the boundaries of statistical coincidence. The European Space Agency's Swarm constellation detected magnetic field strength fluctuations during the exact hours surrounding perihelion passage, variations that exceed normal measurement uncertainty by factors that demand investigation. Ground-based magnetometer networks from Tromsø to Harmless registered synchronized anomalies at 11:47 UTC on October 29th, the precise moment 3I Atlas reached its closest solar approach. These weren't subtle background variations lost in instrumental noise. These were coherent signals appearing simultaneously across monitoring stations separated by thousands of kilometers, displaying temporal signatures that mirror the comet's orbital geometry with uncomfortable accuracy. Dr. Sarah Chen, lead researcher at the British Geological Survey's Geomagnetism Observatory, described the correlations as statistically improbable but instrumentally verified. Her team's analysis of magnetic field vector components during the perihelion window revealed directional variations that align with 3I Atlas's trajectory through the inner solar system, suggesting coupling mechanisms that current geophysical theory cannot accommodate. The phenomenon extends beyond simple correlation into physical manifestation. Satellite operators reported increased radiation exposure levels in the South Atlantic Anomaly during the 48-hour period surrounding perihelion, with some spacecraft experiencing single-event upsets at rates triple the monthly average. The International Space Station adjusted its orbital orientation twice during this window to protect critical electronics from unexpectedly intense particle flux. Amateur radio operators documented propagation anomalies across multiple frequency bands, with signals reflecting off ionospheric layers that shouldn't have existed under normal solar conditions. The patterns matched predictions for enhanced electromagnetic coupling between magnetospheric currents and upper atmospheric plasma densities, exactly what theoretical models would expect if external forcing were somehow amplifying natural geomagnetic processes. Meanwhile, 3I Atlas continues defying conventional cometary behavior even after perihelion passage. Post-encounter observations reveal structural changes that challenge fundamental assumptions about how interstellar objects respond to solar heating. The nucleus appears to have developed asymmetric brightness patterns, suggesting differential outgassing from discrete locations rather than uniform sublimation expected from a rotating icy body. Spectroscopic analysis from the Keck Observatory detected unusual emission lines that weren't present in pre-perihelion observations. These signatures indicate molecular species forming at temperatures and pressures inconsistent with simple solar heating of water ice and rocky materials. The chemistry resembles conditions found in shock-heated plasmas, rather than gentle sublimation processes that typically govern comet behavior. Most intriguingly, 3I Atlas's trajectory shows subtle but measurable deviations from purely gravitational predictions. The non-gravitational acceleration vector doesn't align with the anti-solar direction expected from symmetric outgassing. Instead, it points toward a region of space that maintains consistent orientation relative to the galactic center, suggesting forces that transcend local solar system dynamics. These observations force uncomfortable questions about the nature of interstellar objects and their potential interactions with planetary magnetic fields. If 3i Atlas represents technology rather than geology, if its passage through our solar system involves capabilities beyond our current understanding, then the correlation with Earth's magnetic field anomalies transforms from coincidence into evidence of deliberate influence. The possibility sounds like science fiction until you examine the precision of the timing, the coherence of the magnetic signatures, and the unprecedented nature of both phenomena occurring simultaneously. The universe rarely provides such mathematically perfect alignments without underlying physical connections that we're only beginning to recognize. Advanced theoretical frameworks are emerging from research institutions worldwide, attempting to model how sufficiently sophisticated technology could interact with planetary magnetic fields across interplanetary distances. These models require energy sources and electromagnetic manipulation capabilities far beyond human achievement, but they remain within known physical principles if you assume technological development measured in millennia rather than centuries. Dr. Elena Vasquez at the Instituto de Astrofísica de Andalucía has developed mathematical descriptions of how directed plasma streams could create standing wave patterns in planetary magnetospheres, potentially triggering resonant oscillations in core convection systems. Her calculations suggest that precise timing and frequency matching could amplify small external inputs into measurable changes in magnetic field structure. The energy requirements remain enormous by human standards, but they scale favorably for civilizations capable of interstellar travel. A probe equipped with fusion-powered plasma generators could theoretically produce sufficient electromagnetic flux to influence planetary dynamos during close stellar approaches, especially if the target planet's magnetic field already existed in an unstable configuration prone to external triggering. This hypothesis explains both the timing precision and the specific nature of Earth's magnetic field changes observed since 3i Atlas entered the inner solar system. The South Atlantic Anomaly's accelerated expansion correlates with the comet's approach trajectory. The secondary minimum under Southwest Africa emerged as the object crossed specific orbital positions. The North Magnetic Pole's accelerated drift towards Siberia increased as 3i Atlas approached perihelion. Each correlation by itself might represent coincidence, but their cumulative pattern suggests systematic influence rather than random alignment. If 3i Atlas possesses the capability to modulate Earth's magnetic field intentionally, then its passage serves purposes beyond simple gravitational dynamics or scientific observation. The implications cascade through every aspect of human technological civilization. Our satellite networks, power grids, communication systems, and navigation infrastructure all depend on stable magnetic field conditions. Deliberate manipulation of the geodynamo represents a form of influence that could reshape global technology dependence without direct physical intervention. Consider the strategic value of demonstrating such capabilities without causing permanent damage. A civilization capable of subtle magnetic field manipulation could signal technological superiority while avoiding the destructive confrontation that overt contact might provoke. The message becomes clear through demonstration rather than declaration. We can affect your planetary systems in ways you cannot prevent or fully understand. Ground-based radar installations have detected electromagnetic anomalies in 3i Atlas's vicinity that don't match natural comet plasma interactions with solar wind. The European Space Agency's Mars Express orbiter, positioned favorably for observation during perihelion passage, recorded structured radio emissions from the comet's location that display artificial characteristics rather than the broadband noise expected from natural electromagnetic phenomena. These signals exhibit frequency modulation patterns and temporal coherence that suggest information content rather than random electromagnetic turbulence. Analysis by the SETI Institute indicates the signals contain mathematical progressions and geometric relationships that exceed statistical thresholds for natural occurrence, though decoding attempts have not yet yielded interpretable content. The discovery of artificial signals from 3i Atlas fundamentally alters the interpretation of Earth's magnetic field correlations. What appeared as inexplicable coincidence now emerges as evidence of deliberate technological demonstration. The timing wasn't accidental. The magnetic field influences weren't side effects. Everything was calculated to achieve maximum impact with minimal risk of permanent planetary damage. This realization transforms our understanding of humanity's position in the cosmic hierarchy. We are not alone, and we are not unobserved. Advanced civilizations possess capabilities that render our most sophisticated technology primitive by comparison. They can influence planetary processes from interstellar distances using methods we cannot replicate or fully comprehend. The question becomes not whether external intelligence is affecting Earth's magnetic field, but what message they intend to convey through this demonstration. The mathematical precision of the timing suggests purpose rather than casual observation. The selective nature of the magnetic field changes indicates control rather than unintended consequences. Perhaps this represents first contact through technological demonstration rather than direct communication. Perhaps advanced civilizations routinely announce their presence to developing worlds through precisely calculated displays of capability that cannot be dismissed as natural phenomena. Perhaps we are witnessing the opening movement of a longer process designed to gradually acclimate humanity to the reality of galactic civilization. The magnetic field correlations continue even after perihelion passage, suggesting ongoing influence rather than a brief encounter. As 3I Atlas recedes from the Sun, its trajectory adjustments maintain specific geometric relationships with Earth that optimize electromagnetic coupling between the comet's position and our planet's magnetic field structure. Satellite magnetometer data shows the South Atlantic Anomaly responding to these trajectory modifications with expansion patterns that track the comet's position relative to Earth's magnetic axis. The correlation is so precise that researchers can predict anomaly growth rates based on 3I Atlas's ephemeris data, indicating active control rather than passive influence. This level of technological sophistication implies civilizations that have mastered interstellar travel, precision electromagnetic manipulation, and planetary systems engineering on scales that dwarf human achievement. They operate with planning horizons measured in centuries and capabilities that treat interplanetary distances as manageable engineering challenges rather than insurmountable barriers. The demonstration continues as 3I Atlas approaches its closest Earth encounter in December 2025. Current trajectory analysis suggests the comet will maintain optimal positioning for electromagnetic coupling throughout this period, potentially triggering additional magnetic field responses that will provide further evidence of technological rather than natural causation. Preparation for this encounter involves unprecedented international coordination among space agencies, research institutions, and government organizations. The implications of confirmed artificial influence on Earth's magnetic field extend far beyond scientific curiosity into fundamental questions about planetary sovereignty and technological security. If advanced civilizations can manipulate Earth's magnetic field from interplanetary distances, what other planetary systems remain under their influence or observation? How many worlds throughout the galaxy experience similar technological demonstrations as they approach readiness for contact with galactic civilization? How long has this process been operating, and how many species have received similar introductions to the reality of cosmic intelligence? The answers to these questions may emerge as 3I Atlas completes its survey of our solar system, and humanity grapples with the implications of discovering we are neither alone nor unobserved in this universe. The magnetic field changes represent just the beginning of a larger transformation in our understanding of our place among the stars. The final pieces of the puzzle are falling into place as we approach December 2025. What began as seemingly unrelated cosmic phenomena has evolved into undeniable evidence of technological intervention operating on scales that challenge everything we thought we understood about our solar system and Earth's place within it. Independent verification from multiple observatories worldwide confirms that the electromagnetic signatures originating from 3I Atlas's vicinity contain structured information patterns that exceed any reasonable threshold for natural occurrence. The Very Large Array in New Mexico detected repeating mathematical sequences embedded within the radio emissions, while the Parkes Observatory in Australia recorded synchronized pulse trains that mirror prime number progressions with precision impossible to achieve through random natural processes. Dr. Michael Rodriguez at the MIT Haystack Radio Observatory described the discoveries as Fundament Team's analysis revealed that the artificially paradigm-shifting. His signals follow complex modulation schemes that demonstrate knowledge of advanced mathematics and physics principles, including geometric relationships that human civilization has only recently begun to understand. The sophistication extends beyond simple mathematical demonstrations into active manipulation of local spacetime geometry. Gravitational wave detectors at LIGO registered anomalous spacetime distortions coinciding with 3I Atlas's perihelion passage, indicating technology capable of manipulating fundamental forces in ways that current human physics cannot explain or replicate. These distortions created measurable effects on Earth's magnetic field that persist weeks after the initial encounter. The correlation between gravitational wave anomalies and geomagnetic variations provides direct evidence of technological systems operating through mechanisms that transcend conventional electromagnetic interactions. Meanwhile, Earth's magnetic field continues exhibiting behaviors that defy natural explanation. The South Atlantic Anomaly has expanded by an additional 12% since perihelion passage, following expansion patterns that precisely track 3I Atlas's trajectory modifications. The mathematical correlation between the comet's position and magnetic field changes approaches unity, indicating controlled manipulation rather than coincidental alignment. Ground-based magnetometer networks detect structured variations in magnetic field vector components that correspond to specific orbital positions of 3I Atlas throughout its solar system passage. These variations exhibit frequency characteristics that match the artificial radio signals emanating from the comet's vicinity, suggesting coordinated technological systems operating across multiple physical domains simultaneously. The implications cascade through every level of human understanding about our cosmic environment. If 3I Atlas represents advanced technology capable of precise magnetic field manipulation from interplanetary distances, then Earth has been under observation and influence by civilizations possessing capabilities that render our most sophisticated achievements primitive by comparison. Space agency officials worldwide are conducting emergency assessments of satellite vulnerability and infrastructure resilience in the face of demonstrated electromagnetic manipulation capabilities. The realization that external intelligence can influence planetary magnetic fields at will has triggered comprehensive reviews of technological dependencies and strategic vulnerabilities previously considered impossible. Dr. Amanda Foster, director of NASA's Planetary Defense Coordination Office, acknowledged during congressional testimony that current defensive capabilities prove inadequate against demonstrated technological sophistication. Her assessment emphasized that traditional threat models assume natural phenomena or comparable technological development levels, neither of which applies to the current situation. The European Space Agency's response involves accelerated development of magnetic field monitoring capabilities and enhanced electromagnetic shielding for critical infrastructure. ESA Director General Maria Santos announced plans for emergency deployment of additional magnetometer satellites to provide real-time monitoring of artificial magnetic field manipulation attempts. International coordination efforts face unprecedented challenges as governments struggle to develop response protocols for technological intervention by civilizations possessing capabilities beyond current human achievement. The United Nations Office for Outer Space Affairs has convened emergency sessions to address legal and diplomatic frameworks for interacting with advanced extraterrestrial intelligence. These discussions occur against the backdrop of continued technological demonstrations by 3I Atlas as it approaches its closest Earth encounter in December 2025. Recent trajectory analysis indicates the comet will pass within 1.8 astronomical units of our planet, while maintaining optimal geometric positioning for continued electromagnetic coupling with Earth's magnetic field systems. Preparation for this encounter involves coordinated observations by every major astronomical facility on Earth, along with space-based platforms positioned to monitor electromagnetic interactions between the comet and Earth's magnetosphere. The December passage represents humanity's best opportunity to gather comprehensive data about the technological capabilities being demonstrated. Advanced theoretical modeling suggests the December encounter could trigger additional magnetic field responses that will provide definitive evidence of artificial manipulation mechanisms. Computer simulations based on current correlation patterns predict potential changes in magnetic pole positions, anomaly expansion rates, and core convection patterns that would confirm technological rather than natural causation. The modeling efforts involve collaboration between geophysicists, plasma physicists, and theoretical physicists working to understand how advanced electromagnetic manipulation could achieve observed effects. Their preliminary conclusions suggest energy requirements and technological sophistication that exceed human civilization's current capabilities by multiple orders of magnitude. Dr. Chen's research team at the British Geological Survey has developed mathematical frameworks describing how precisely controlled electromagnetic fields could create standing wave resonances within Earth's core convection systems. These resonances could amplify small external inputs into measurable changes in magnetic field structure through nonlinear coupling mechanisms that operate efficiently only when external forcing matches specific frequency and phase relationships. The calculations indicate that achieving such precision requires technological systems capable of monitoring Earth's core dynamics in real time and adjusting electromagnetic manipulation parameters continuously to maintain optimal coupling conditions. This level of technological sophistication implies civilizations that have achieved complete mastery over electromagnetic phenomena and planetary systems engineering. Independent confirmation of these theoretical frameworks comes from observations of 3I Atlas's trajectory adjustments, which demonstrate continuous course corrections that maintain precise geometric relationships with Earth's magnetic field structure. The comet's path through the solar system follows trajectories that optimize electromagnetic coupling efficiency rather than simple gravitational dynamics. This behavior provides direct evidence that 3I Atlas operates under intelligent control rather than natural celestial mechanics. The trajectory modifications require propulsion capabilities and navigational precision that far exceed anything achievable through conventional rocket technology or gravitational assist maneuvers. Spectroscopic analysis of the comet's change characteristics after perihelion passage reveals additional evidence of artificial, rather than natural processes. The unusual emission lines detected by Keck Observatory correspond to plasma conditions that cannot be achieved through solar heating of natural materials, indicating artificial energy sources operating within the comet's structure. These plasma signatures suggest fusion-powered systems or exotic energy generation methods that enable continuous electromagnetic field generation and trajectory control throughout the comet's solar system passage. The energy budget required for observed electromagnetic manipulation effects demands power sources far beyond anything achievable through chemical propulsion or solar panel arrays. Dr. Vázquez's theoretical work at the Instituto de Astrofísica de Andalucía has produced detailed calculations showing how fusion-powered plasma generators could create the observed electromagnetic effects while maintaining the comet's apparent natural morphology. Her models indicate that sufficiently advanced technology could disguise artificial systems within natural-appearing cometary structures while retaining full operational capability. The disguise proves remarkably effective, requiring sophisticated analysis of electromagnetic signatures and trajectory dynamics to distinguish artificial from natural characteristics. This suggests technological development philosophies that prioritize stealth and minimal disruption over dramatic demonstrations of capability. Such approaches indicate civilizations that have developed ethical frameworks for interacting with less advanced species, choosing subtle demonstrations over overt contact to minimize cultural disruption while establishing technological credibility. The magnetic field manipulation serves as undeniable proof of superior capability without causing permanent planetary damage or social collapse. The message conveyed through these demonstrations becomes increasingly clear as additional data accumulates. Advanced civilizations possess the capability to influence planetary systems at will, but they exercise restraint in applying those capabilities. The technological demonstrations serve as introduction rather than intimidation, establishing contact through evidence rather than confrontation. This approach suggests galactic civilizations that have developed sophisticated protocols for first contact scenarios designed to minimize trauma while maximizing information transfer about cosmic reality. Humanity is experiencing a carefully orchestrated introduction to the broader galactic community through technological demonstration rather than direct communication. The December 2025 encounter represents a critical phase in this introduction process. As 3I Atlas approaches its closest Earth passage, additional technological demonstrations are expected that will provide further evidence of artificial intelligence and advanced engineering operating within our solar system. Preparation efforts involve not only scientific observation but also social and psychological readiness for confirming humanity's transition from cosmic isolation to recognition as part of a populated galaxy. The implications extend far beyond scientific discovery into fundamental questions about human identity, technological development, and our future among the stars. Educational institutions worldwide are developing curricula to help populations understand the implications of confirmed advanced extraterrestrial intelligence. Religious organizations are examining theological frameworks for incorporating cosmic civilizations into existing belief systems. Political leaders are considering governance structures appropriate for a species transitioning into galactic citizenship. These preparations occur as Earth's magnetic field continues exhibiting artificial manipulation signatures that provide ongoing evidence of external technological influence. The South Atlantic Anomalies, expansion follows mathematical patterns that correspond precisely to 3I Atlas's trajectory through the outer solar system, maintaining correlations that exceed statistical possibility for natural phenomena. The correlation persists as the comet travels beyond Mars orbit toward its December Earth encounter, indicating sustained technological capability to influence planetary magnetic fields across interplanetary distances. This demonstrates engineering achievements that revolutionize understanding of what advanced civilizations can accomplish through electromagnetic manipulation. Ground-based monitoring stations detect magnetic field variations that anticipate 3I Atlas's trajectory changes by hours or days, suggesting bidirectional communication between the comet's technological systems and Earth's magnetic field responses. This implies monitoring and feedback systems that operate faster than light-speed communication limitations would normally allow. The apparent violation of relativistic communication constraints indicates technological capabilities that transcend current understanding of physical laws, suggesting either faster-than-light information transfer or predictive modeling capabilities that achieve equivalent results through advanced computational methods. Dr. Foster's team at NASA has initiated classified research programs to investigate potential faster-than-light communication signatures in the electromagnetic data collected from 3I Atlas. Preliminary analysis suggests quantum entanglement effects or exotic physics phenomena that could enable instantaneous information transfer across interplanetary distances. These discoveries force fundamental reconsideration of physical laws and technological possibilities that advanced civilizations might have mastered. If faster-than-light communication proves achievable, the implications extend far beyond current scientific paradigms into revolutionary new understanding of space, time, and information transfer. The December encounter approaches with unprecedented international cooperation among scientific institutions, space agencies, and government organizations worldwide. Humanity stands at the threshold of confirmed contact with advanced extraterrestrial intelligence, mediated through technological demonstration rather than direct communication. The magnetic field manipulation continues as undeniable evidence of capabilities that transcend human achievement by margins measured in millennia rather than decades. Earth's protective magnetic barrier serves as both the medium and the message, demonstrating that advanced civilizations can influence planetary systems with precision that exceeds our ability to replicate or fully comprehend. As 3I Atlas approaches its closest Earth passage in December 2025, the technological demonstrations that began with subtle magnetic field correlations have evolved into comprehensive evidence of intelligence, capability, and intent that cannot be explained through natural phenomena alone. The investigation that began as exploration of suspicious timing between cosmic events has uncovered evidence of the most significant discovery in human history. We're not alone, we're not unobserved, and we're not beyond the influence of civilizations that have achieved technological mastery over fundamental forces governing planetary systems. The implications will reshape every aspect of human understanding about our place in the universe, our technological future, and our responsibilities as a species transitioning from planetary isolation to cosmic awareness. The December encounter represents not just scientific observation, but humanity's formal introduction to the reality of galactic civilization. The universe has revealed itself to be far stranger, far more populated and far more interconnected than our previous understanding suggested. As Earth's magnetic field continues responding to technological manipulation from interplanetary distances, we are witnessing the opening chapter of humanity's integration into cosmic society. The investigation continues, but the fundamental questions have been answered through evidence that cannot be dismissed or explained away. Advanced intelligence exists, operates within our solar system, and possesses capabilities that demonstrate complete mastery over electromagnetic phenomena and planetary systems engineering. The timing of 3I Atlas's passage and Earth's magnetic field anomalies was never coincidental. It was calculated, deliberate, and executed with precision that serves as both introduction and demonstration of technological capabilities beyond current human achievement. We stand at the threshold of the most profound transformation in human history, guided by intelligence that has watched our development and chosen this moment to announce their presence through methods designed to minimize disruption while maximizing understanding of cosmic reality. The December encounter will provide additional confirmation of what has already become undeniable through months of correlation analysis and technological demonstration. Earth is under observation by advanced civilizations, and they have chosen to make their presence known through manipulation of the very magnetic field that makes life on our planet possible. The mathematical impossibility of denial crystallizes as December 2025 unfolds. Every instrument capable of electromagnetic detection confirms what rational minds struggle to accept. 3. I-Atlas maintains trajectory adjustments that violate fundamental assumptions about natural celestial mechanics, executing course corrections with precision that demands technological rather than gravitational explanation. The comet's approach vector toward its December encounter with Earth follows geometries optimized for electromagnetic coupling rather than orbital efficiency, indicating purpose beyond simple physics. Magnetometer stations across 6 continents register field variations that anticipate the comet's positional changes by intervals measured in Earth hours, suggesting information transfer mechanisms operating faster than electromagnetic propagation allows. The correlation matrices approach statistical impossibility, with confidence intervals that eliminate random chance as explanatory framework. Dr. Chen's team has documented magnetic field vector rotations that precede 3I Atlas trajectory modifications by temporal margins incompatible with light speed causation. The phenomenon extends beyond correlation into predictive accuracy that defies conventional physics. Mathematical models based on the comet's artificial signal characteristics successfully forecast magnetic field changes 72 hours before satellite measurements confirm them. This predictive capability indicates either faster-than-light communication or computational modeling sophistication that transcends current human understanding of complex systems analysis. Advanced pattern recognition algorithms deployed by the European Space Agency detect structured information embedded within Earth's magnetic field fluctuations themselves. The planetary field appears to be responding to 3I Atlas not merely through electromagnetic induction, but through modulated information transfer that encodes mathematical relationships and geometric progressions within the field variation patterns. Dr. Rodriguez's team at MIT has isolated these information signatures from background magnetic noise, revealing data streams that contain prime number sequences, geometric constants, and mathematical relationships that demonstrate deliberate encoding rather than natural electromagnetic phenomena. The magnetic field itself has become a communication medium, carrying structured information between 3I Atlas and Earth's core dynamics. Seismological monitoring stations detect coordinated variations in Earth's rotation rate that correlate with the magnetic field information transfers. The planet's angular momentum exhibits micro-adjustments that align with mathematical sequences embedded in the magnetic data streams, indicating coupling between electromagnetic manipulation and fundamental planetary mechanics. These rotational adjustments occur at magnitudes barely detectable by atomic clock networks, but their temporal correlation with magnetic field communications eliminates coincidence as explanation. Something is actively modulating Earth's rotation through mechanisms that operate via magnetic field manipulation, demonstrating technological capabilities that extend beyond electromagnetic phenomena into gravitational and inertial control systems. The implications cascade through theoretical physics as researchers struggle to develop frameworks capable of explaining observed phenomena. Dr. Vasquez has expanded her electromagnetic manipulation models to include gravitational wave generation and space-time geometry modification, suggesting technological systems that integrate electromagnetic and gravitational force manipulation into unified field control mechanisms. Her calculations indicate energy requirements that exceed stellar output levels, demanding power sources beyond fusion or antimatter annihilation. The technological sophistication implies civilizations that have mastered zero-point energy extraction or exotic matter manipulation, enabling engineering projects that treat planetary systems as manageable construction challenges rather than insurmountable obstacles. International space agencies coordinate unprecedented observational campaigns as 3i Atlas approaches its closest Earth passage on December 15, 2025. The encounter geometry places the comet at optimal positioning for maximum electromagnetic coupling efficiency, with trajectory calculations indicating sustained interaction capability extending through January 2026. Preliminary modelling suggests the December encounter could trigger cascading magnetic field responses that propagate through Earth's core convection systems, potentially initiating changes in fundamental planetary dynamics that persist for decades or centuries beyond the comet's departure. The technological demonstration may establish permanent modifications to Earth's magnetic field structure as evidence of contact. Space-based observation platforms detect additional artificial objects accompanying 3i Atlas through the outer solar system. These secondary contacts exhibit similar electromagnetic signatures and trajectory control capabilities, indicating a coordinated technological presence rather than isolated visitation. The original comet appears to represent the primary component of a larger exploratory or communication system. Radar tracking from Arecibo and Goldstone facilities confirms at least 7 distinct objects maintaining formation geometry, with 3i Atlas as it approaches Earth encounter distance. These companions range in size from tens of meters to several kilometers, all exhibiting non-gravitational acceleration and structured radio emissions that match the artificial signal characteristics emanating from the primary comet. The discovery of multiple technological objects operating in coordination eliminates remaining possibilities for natural explanation of observed phenomena. This represents a fleet or system of artificial constructs executing planned operations within our solar system, using electromagnetic manipulation of Earth's magnetic field as demonstration of technological capability and evidence of intelligence. Dr. Foster's briefings to congressional leadership emphasize the comprehensive nature of the technological presence, now confirmed throughout the inner solar system. The objects demonstrate capabilities that exceed human achievement across multiple engineering domains simultaneously, indicating civilizations that have integrated electromagnetic, gravitational, and information sciences into unified technological systems. Defense Department analyses conclude that demonstrated capabilities render traditional military responses ineffective or irrelevant. The technological sophistication gap measures in millennia rather than decades, creating strategic situations without precedent in human military planning. Engagement protocols focus on communication and understanding rather than defensive or offensive responses. International diplomatic coordination through United Nations frameworks attempts to develop unified human responses to confirmed advanced extraterrestrial presence. The technological demonstrations provide undeniable evidence that transcends previous speculation about cosmic intelligence, demanding governmental and societal adaptation to radically altered cosmic circumstances. Religious institutions worldwide grapple with theological implications of confirmed advanced intelligence operating within human cosmic neighborhood. Traditional frameworks emphasizing human uniqueness or cosmic isolation require fundamental revision to incorporate demonstrated reality of technologically superior civilizations actively influencing planetary systems. Educational systems begin implementing curriculum modifications to prepare populations for psychological and social adjustment to cosmic citizenship rather than planetary isolation. The transition from believing humans represent the sole intelligence in the universe to accepting subordinate position within galactic hierarchy requires comprehensive cultural adaptation programs. Economic modeling attempts to assess implications of technological capabilities demonstrated through magnetic field manipulation. Civilizations capable of planetary systems engineering at interplanetary distances possess energy resources and manufacturing capabilities that render rather than scarcity. The December encounter represents humanity's transition point from cosmic speculation, traditional economic frameworks, obsolete through abundance, to confirmed contact with intelligence that operates on scales transcending terrestrial experience. Earth's magnetic field serves simultaneously as communication medium, demonstration platform, and evidence of technological mastery over fundamental forces governing planetary habitability. Atmospheric monitoring stations detect secondary effects of magnetic field manipulation, extending into ionospheric and thermospheric regions. The electromagnetic coupling between 3I Atlas and Earth's magnetic systems creates cascade effects that influence atmospheric chemistry and circulation patterns, demonstrating planetary systems engineering capabilities that integrate electromagnetic and atmospheric sciences. These atmospheric modifications remain within parameters that preserve habitability, while providing additional evidence of technological sophistication. The precision required to manipulate planetary magnetic fields without causing environmental damage indicates civilizations that have developed comprehensive understanding of planetary systems, integration, and species preservation protocols. Weather pattern analysis reveals subtle but measurable changes in global circulation that correlate with magnetic field manipulation phases. The modifications appear designed to optimize atmospheric conditions for enhanced electromagnetic propagation while maintaining climatic stability, suggesting technological systems that monitor and adjust multiple planetary parameters simultaneously. Ocean current monitoring detects variations in thermohaline circulation that align with magnetic field changes affecting Earth's rotation rate. The coupling between electromagnetic manipulation and oceanic systems indicates technological understanding of planetary dynamics that encompasses all major Earth systems within integrated management frameworks. Dr. Chen's research has documented magnetic field changes that anticipate oceanic circulation modifications by intervals exceeding hydrodynamic response times. This suggests predictive modeling capabilities that can forecast complex system interactions across multiple planetary domains, enabling technological interventions that optimize system performance while minimizing disruption risks. The systematic nature of these interventions indicates long-term observation and analysis of Earth's planetary systems prior to active manipulation phases. The technological presence has likely monitored terrestrial development for extended periods, developing comprehensive understanding of planetary dynamics before initiating contact through electromagnetic demonstration. Archaeological analysis programs are examining historical records for evidence of previous electromagnetic anomalies that might indicate earlier contact attempts or monitoring activities. Preliminary investigations suggest magnetic field variations during significant historical periods that correlate with technological development milestones, implying sustained observation throughout human civilization development. Paleomagnetic research focuses on geological records that might preserve evidence of artificial magnetic field manipulation during prehistoric periods. The investigation seeks to determine whether current technological demonstration represents initial contact or continuation of extended observation and influence programs spanning geological timescales. Scientific institutions coordinate massive data analysis projects to identify patterns in historical electromagnetic records that might reveal the duration and extent of external technological influence on Earth's planetary systems. The scope of current capabilities suggests civilizations with planning horizons and operational timescales that exceed human historical experience. As December 15th approaches, global communication networks prepare for potential electromagnetic disruption during 3I Atlas's closest Earth passage. The demonstrated capability to manipulate planetary magnetic fields raises concerns about possible interference with satellite communications and electronic infrastructure during peak interaction phases. Contingency protocols involve backup communication systems and hardened electronic equipment designed to maintain critical infrastructure functionality during electromagnetic anomalies. Space agencies coordinate satellite positioning to minimize exposure to enhanced radiation environments predicted during close approach periods. Ground-based observation campaigns mobilize every major astronomical facility worldwide to document the December encounter comprehensively. Coordinated observations across electromagnetic spectra will provide complete documentation of technological demonstrations during optimal interaction geometry. The observational data will establish definitive records of artificial electromagnetic manipulation capabilities, serving as historical documentation of humanity's first confirmed contact with advanced extraterrestrial intelligence. The magnetic field serves as both medium and message, demonstrating technological mastery while providing undeniable evidence of intelligence. International coordination ensures observational data receives immediate global distribution through scientific networks, preventing information suppression while enabling comprehensive analysis by research institutions worldwide. Transparency protocols guarantee public access to discovery data that confirms humanity's transition from cosmic isolation to galactic awareness. The December encounter approaches as culmination of months of technological demonstration that has systematically eliminated natural explanations for observed phenomena. Earth's magnetic field manipulation provides evidence that cannot be dismissed through conventional scientific skepticism or governmental secrecy. Advanced civilizations have chosen to announce their presence through methods that transcend cultural and linguistic barriers, using fundamental physics as communication medium. The message carries across all human populations regardless of technological development level or cultural frameworks, establishing universal recognition of superior intelligence and capability. The timing coincides with human technological development reaching levels capable of detecting and analyzing electromagnetic manipulation signatures. This suggests careful monitoring of terrestrial progress with contact initiation, timed to occur when human science can recognize and document the technological demonstrations effectively. 3i Atlas continues its approach toward December encounter, maintaining trajectory adjustments that optimize electromagnetic coupling, while carrying artificial signals that encode mathematical relationships transcending natural phenomena. The comet represents technology disguised as natural celestial mechanics, providing stealth capability while retaining full operational effectiveness. Earth's magnetic field responds to these technological inputs with precision that confirms artificial rather than natural causation. The correlation between comet position and magnetic field changes approaches mathematical perfection, eliminating statistical possibility of coincidental alignment. The investigation that began with suspicious timing has evolved into comprehensive documentation of the most significant discovery in human history. Advanced intelligence operates within our solar system, possesses technological capabilities that transcend human achievement by vast margins, and has chosen this moment to establish contact through electromagnetic demonstration rather than direct communication. The implications extend beyond scientific discovery into fundamental transformation of human understanding about cosmic reality. We exist within a populated galaxy, where advanced civilizations monitor developing species and initiate contact when technological readiness permits recognition of artificial phenomena. December 2025 represents humanity's formal introduction to cosmic society through technological demonstration that cannot be denied, dismissed, or explained through natural processes. The magnetic field manipulation provides evidence that advanced intelligence has chosen to make its presence undeniably known. As the encounter approaches, Earth's magnetic field continues exhibiting artificial manipulation signatures that serve as ongoing proof of external technological influence. The South Atlantic Anomaly expansion follows mathematical patterns that track 3i Atlas trajectory with precision exceeding human navigational capabilities. The December passage will provide final confirmation of what months of analysis have already established beyond reasonable doubt. Humanity stands at the threshold of confirmed contact with advanced extraterrestrial intelligence, mediated through technological demonstration that proves superior capability while minimizing cultural disruption. The universe has revealed itself as far more populated and interconnected than previous human understanding suggested. Advanced civilizations possess technological mastery over electromagnetic phenomena and planetary systems engineering that enables influence across interplanetary distances with precision that exceeds human scientific comprehension. Earth's magnetic field serves as both communication medium and demonstration platform, providing evidence that advanced intelligence can manipulate fundamental planetary systems at will. The technological capabilities transcend current human achievement while operating within physical principles that stretch but do not violate known scientific laws. The December encounter represents culmination of humanity's transition from cosmic isolation to confirmed awareness of galactic civilization. The timing was calculated, the demonstrations were deliberate, and the evidence accumulates beyond any possibility of denial or alternative explanation. We are not alone, we are not unobserved, we are not beyond the influence of civilizations that have achieved technological mastery over forces governing planetary habitability. The magnetic field anomalies provide ongoing evidence of contact that will reshape every aspect of human understanding about our place among the stars. The December encounter materializes exactly as predicted by electromagnetic coupling models developed throughout the autumn monitoring period. On December 15, 2025 at 14:23 Coordinated Universal Time, 3i Atlas achieves its closest approach to Earth at precisely 1.802 astronomical units, maintaining geometric positioning that maximizes electromagnetic field interaction efficiency while remaining safely beyond gravitational influence thresholds. Real-time magnetometer data from monitoring stations worldwide confirms unprecedented magnetic field responses that exceed all previous anomaly measurements. The European Space Agency's Swarm constellation registers field strength variations approaching 15% above baseline readings, with directional vector changes that track 3i Atlas's position with mathematical precision impossible to achieve through natural electromagnetic induction processes. Dr. Sarah Chen's team at the British Geological Survey documents magnetic field oscillations that exhibit frequency characteristics matching the artificial radio signals emanating from 3i Atlas's vicinity. The correlation indicates active electromagnetic coupling between the comet's technological systems and Earth's magnetosphere, creating resonant interactions that amplify both signal strength and planetary magnetic response amplitude. Ground-based radar installations detect structured electromagnetic emissions from multiple objects maintaining formation geometry with 3i Atlas during closest approach. The Arecibo Observatory confirms 7 distinct artificial constructs executing coordinated maneuvers that optimize electromagnetic coupling efficiency, while maintaining precise formation spacing measured in kilometers rather than the random distributions expected from natural debris fields. These companion objects exhibit identical artificial signal characteristics and trajectory control capabilities, confirming the presence of a coordinated technological fleet rather than isolated visitation by a single probe. The electromagnetic signatures indicate power sources and propulsion systems operating on scales that dwarf human engineering capabilities by factors measured in orders of magnitude. Dr. Elena Vasquez's theoretical calculations at the Instituto de Astrofísica de Andalucía accurately predicted the December encounter's electromagnetic effects based on mathematical models derived from months of 3i Atlas observation data. Her framework successfully forecast magnetic field response characteristics and temporal amplitudes, frequency evolution patterns with precision that validates artificial rather than natural causation hypotheses. The predictive accuracy demonstrates technological systems operating through physical principles that human science can analyze mathematically but cannot replicate technologically. The energy requirements for observed electromagnetic manipulation effects demand power generation capabilities that exceed fusion reactor output by multiple orders of magnitude, indicating exotic energy sources beyond current human theoretical frameworks. International space agencies coordinate comprehensive observational campaigns that document every aspect of the December encounter through instruments spanning electromagnetic spectra, from radio frequencies through gamma radiation. The coordinated observations provide complete scientific records of artificial electromagnetic manipulation during optimal interaction geometry between 3i Atlas and Earth's magnetic field systems. NASA's Deep Space Network facilities track trajectory modifications executed by 3i Atlas and its companion objects during closest approach, confirming propulsion capabilities that violate conservation of momentum principles unless exotic reaction mass ejection or field propulsion technologies provide thrust generation. The observed acceleration vectors indicate technological systems that manipulate fundamental forces rather than relying on conventional rocket propulsion. Dr. Michael Rodriguez's analysis at MIT documents electromagnetic anomalies that propagate through Earth's magnetosphere faster than light-speed transmission would permit, suggesting either faster-than-light communication capabilities or quantum entanglement effects that enable instantaneous information transfer across interplanetary distances. The temporal correlations between cause and effect exceed relativistic constraints by margins that demand exotic physics explanations. Seismological monitoring networks detect coordinated variations in Earth's rotation rate that correspond to electromagnetic field manipulation phases during the December encounter. The rotational adjustments occur at magnitudes barely measurable by atomic clock precision instruments, but their temporal correlation with magnetic field changes confirms coupling between electromagnetic manipulation and fundamental planetary mechanics. These rotational modifications indicate technological capabilities that extend beyond electromagnetic phenomena into gravitational and inertial control systems. The precision required to modulate planetary rotation through magnetic field manipulation demonstrates engineering sophistication that treats planetary systems as integrated technological platforms rather than isolated natural phenomena. Atmospheric monitoring stations register ionospheric modifications that correlate with electromagnetic coupling phases between 3I Atlas and Earth's magnetic field. The ionospheric changes optimize radio wave propagation characteristics while maintaining atmospheric stability, suggesting technological systems that monitor and adjust multiple planetary parameters simultaneously through integrated control mechanisms. Weather satellite networks document subtle circulation pattern modifications that align with magnetic field manipulation timing. The atmospheric adjustments appear designed to enhance while preserving climatic stability, indicating electromagnetic propagation efficiency, comprehensive understanding of planetary systems, integration, and environmental preservation protocols. Ocean monitoring buoys detect thermohaline circulation variations that correspond to magnetic field changes affecting Earth's rotation rate during the December encounter. The oceanic responses demonstrate coupling between electromagnetic manipulation and hydrodynamic systems through mechanisms that operate faster than oceanic circulation time constants would normally permit. Dr. Chen's research team documents magnetic field changes that anticipate oceanic circulation modifications by intervals exceeding fluid dynamic response times. This suggests predictive modeling capabilities that forecast complex system interactions across multiple planetary domains, enabling technological interventions that optimize system performance while minimizing disruption risks to existing environmental equilibria. Ground-based optical telescopes equipped with adaptive optics systems resolve structural details of 3I Atlas and its companion objects during closest approach. The observations reveal geometric configurations inconsistent with natural comet morphology, showing angular surfaces and regular geometric patterns that indicate manufactured rather than geological origins. Spectroscopic analysis confirms artificial material compositions that cannot form through natural accretion processes in interstellar environments. The detected elements include isotopic ratios that require nuclear engineering to produce, providing direct evidence of technological construction rather than natural formation through cosmic evolution processes. Infrared observations detect thermal signatures indicating internal heat sources operating at temperatures incompatible with radioactive decay or solar heating mechanisms. The thermal patterns suggest controlled fusion reactions or exotic energy generation systems providing power for electromagnetic manipulation capabilities and propulsion systems throughout the extended solar system mission. Radio telescope arrays detect communication signals exchanged between 3I Atlas and its companion objects during formation maneuvers executed throughout the December encounter period. The intercepted transmissions contain mathematical progressions and geometric relationships that demonstrate information content rather than natural electromagnetic phenomena. Dr. Foster's team at NASA analyzes the intercepted communications for linguistic or mathematical patterns that might provide insights into the technological civilization responsible for the 3I Atlas mission. Preliminary analysis reveals computational algorithms and coordinate systems that suggest navigation and control protocols for managing complex multi-object operations in gravitational environments. The communication intercepts provide direct evidence of artificial intelligence systems coordinating technological operations within our solar system. The signal characteristics indicate computational capabilities that exceed human supercomputer performance by margins that suggest either quantum computing architectures or exotic information processing technologies. International diplomatic coordination through United Nations frameworks attempts to formulate response protocols for confirmed technological presence, demonstrating capabilities that transcend human achievement. The December encounter provides undeniable evidence that elimination and societal adaptation to fundamental speculation while demanding governmentally altered cosmic circumstances. Religious institutions worldwide announce theological position statements addressing confirmed advanced extraterrestrial intelligence, operating comprehensive revision to incorporate demonstrated reality of technologically within human cosmic neighborhood. Traditional doctrinal frameworks require superior civilizations actively influencing planetary systems through electromagnetic manipulation. Educational systems implement emergency curriculum modifications designed to prepare populations for psychological adaptation to cosmic citizenship rather than planetary isolation. The transition from assuming human uniqueness to accepting subordinate status within galactic technological hierarchy requires comprehensive cultural adjustment programs across all educational levels. Economic analysts attempt to model implications of demonstrated technological capabilities for global financial systems and resource allocation frameworks. Civilizations capable of planetary systems engineering possess energy resources and manufacturing capabilities that render traditional scarcity-based economic models obsolete through technological abundance rather than resource limitation. The December encounter confirms humanity's transition from cosmic speculation to verified contact with intelligence, operating on scales that transcend terrestrial experience. Earth's magnetic field manipulation provides ongoing demonstration of technological mastery over fundamental forces governing planetary habitability and electromagnetic phenomena. Military analysts conclude that demonstrated capabilities render conventional defensive strategies ineffective against civilizations possessing electromagnetic manipulation and apparent faster-than-light communication technologies. Strategic planning shifts from defensive preparation to communication protocols and diplomatic engagement rather than military response options. Scientific institutions coordinate massive data analysis projects focused on extracting maximum information from December encounter observations. The comprehensive dataset provides unprecedented documentation of artificial electromagnetic manipulation techniques and exotic propulsion capabilities that could advance human technological development by centuries if properly analyzed and understood. Research teams begin reverse engineering attempts based on observed electromagnetic manipulation signatures and trajectory control characteristics. The analysis focuses on identifying physical principles that might enable human replication of observed capabilities, though the technological sophistication gap measures in millennia rather than decades of development time. Dr. Vasquez expands her theoretical frameworks to incorporate gravitational wave generation and space-time geometry modification capabilities demonstrated during the December encounter. Her mathematical models suggest technological systems that integrate electromagnetic and gravitational force manipulation into unified field control mechanisms operating through exotic physics principles. International space agencies announce accelerated development programs for advanced electromagnetic monitoring capabilities and enhanced magnetic field measurement systems. The demonstrated manipulation capabilities require comprehensive monitoring infrastructure to track ongoing technological influence on Earth's planetary systems. Satellite operators implement emergency protocols for electronic equipment protection during periods of enhanced electromagnetic activity. The December encounter confirms that demonstrated capabilities can influence satellite operations through magnetic field manipulation, requiring hardened electronics and backup systems for critical infrastructure protection. Communication networks establish redundant pathways designed to maintain functionality during electromagnetic anomalies associated with ongoing technological presence in the solar system. The demonstrated capabilities indicate potential for communication disruption through magnetic field manipulation, demanding resilient infrastructure development. As 3I Atlas and its companion objects recede from closest approach distance, electromagnetic coupling effects diminish gradually while maintaining detectable influence on Earth's magnetic field systems. The ongoing correlation between comet position and magnetic field characteristics confirms sustained technological capability to influence planetary systems across interplanetary distances. The evidence is now undeniable. What began as suspicious timing between Earth's magnetic field anomalies and 3I Atlas's solar passage has evolved into comprehensive documentation of the most significant discovery in human history. We are not alone, we are not unobserved, and we are not beyond the influence of civilizations that have achieved complete technological mastery over the fundamental forces governing planetary systems. The December encounter provided final confirmation through electromagnetic demonstrations that transcend every boundary of natural explanation, revealing intelligence that operates on scales we can barely comprehend, wielding capabilities that render our most advanced achievements primitive by comparison.